Hello everyone. Based on several requests that I was receiving over the past couple of months, I thought of coming up with a end-to-end data engineering project, and that too in the Azure side, right? So in this project you will get a complete idea on how a project is handled in the real world in the industry, right? And this should be really helpful for your interviews, or even if you are working in Azure, this should help you in your day-to-day work. Now, I'm sure most of you would be aware of me. My name is Sumit. I completed my master's from NIT Trichy, and then I've worked for companies like Cisco and VMware. I majorly worked in the big data area. For last 5 years, I have been training candidates in the data engineering space, and I offer an ultimate data engineering program, which is a quite extensive program, 32 weeks program, and that is a program which has impacted several careers and has changed several lives. Right? So you can check that program. The link to the program is in the description. Without any delay, let's get started with the project. So, what is this project all about? So, first thing that I will talk is the technology on which this project is based. This project will be based on Azure Data Engineering Stack, right? Which is a very trending stack, right? So I was getting a lot of demand that, okay, sir, can you develop a project around Azure Data Engineering? So I thought of developing a end-to-end project, taking a real use case and applying whatever I could, right? So this will give you a very, very good idea when you are going for interviews. And even if you do not think from an interview perspective, when you are working in your companies, this should be helping you a lot. Now, what domain we will be working on, right? So there are multiple domain: healthcare, banking, retail, finance, insurance, right? So this will be around healthcare domain, which is a very trending domain. Now, even if you are not from this domain, it's okay because you will get a complete idea about the end-to-end pipeline, which is trending, right? But for people who are from healthcare, then you can relate with the data sets and all also. So this project is around healthcare revenue cycle management, right? Commonly known as RCM, healthcare revenue cycle management, RCM, right? And I'm sure if some of you are my students working in healthcare domain, many of you would be working on RCM domain. By the way, if you do not know about me, my name is Sumit, and I offer data engineering programs. Right now, a very trending program is the Ultimate Data Engineering Program. And in case if you want to know more about it, you can check under the comment section. You can check under the description of this, right? Where you will get the link to my website. So, anyways, let's get started. So, what is this RCM and what exactly we have to do? So, let's understand about this domain a little bit so that you get a context on what we have to work on or what problem statement we are going to solve. Okay. So, RCM is the process. RCM is the process that hospitals use to manage the financial aspect. So I will first write it and then I will explain because I want to go little slow on the domain side because someone who is not from this domain should not get lost, right? So you should be able to understand it very well, and I will try to talk in layman terms. So RCM is the process that hospitals use to manage the financial aspects financial aspects, right? And the financial aspects start from the moment a patient schedule an appointment. Let's say if someone is going for let's say someone is getting a viral fever, someone visits a hospital. From that time onwards till the time the doctor actually gets paid, right? So the end to end cycle, right? From the time the patient schedules an appointment till the time till the time the provider gets paid. Provider, in the sense, you can think of a hospital or a doctor. That means end to end. That means first a patient pays to the hospital, and the hospital internally will pay salaries and all of that stuff in between, right? So there is a lot, I'll talk about it, but it's mainly to deal with these financial aspects about the patient paying the hospital, and then hospital has enough of I mean revenue supply so that they can manage their things. So I want to give a simplified breakdown for this. So here is a simplified breakdown, and I am writing this note so that these notes become handy for you, right? So how this starts? It starts with a patient visit. It starts with a patient visit, right? The process starts with a patient visit. So when a patient visits a hospital, it can be a big hospital or it can be a small clinic, whatever is that, their details, the patient details, like the insurance coverage or whatever details are there, are collected. So patient details are collected by the hospital or clinic. Now, why these details are collected? So mainly I am talking about the insurance details here. It will be other details also, but insurance details is what is very very important, and these details are collected. Now this ensures that the provider in the sense here the hospital, so this ensures provider knows who will pay for the services. And I am trying to use the terms which are used in this particular domain. So provider in this context will mean a hospital, but in some context it will mean the doctor also. So patient is a patient, as you know, but provider is something that you might not understand, so I am giving you an idea that context wise it will be either hospital or a doctor, the one who is providing the services. So this ensures providers knows who will pay for the services. So who will pay? Either it will be insurance company who will pay, or the patient will pay, or both will pay. That means some part the insurance will pay and some part you will pay. Because, for example, you might, let's say, go through, or someone goes through a surgery, and the bill for that in India, let's say it is 3 lakh, right? Or let's say if you talk about US, even though the project that we are building is a US based project, think that it's a US based hospital that we are referring to. So let's say that the cost of this surgery is, let's say, uh, 20,000 USD, right? Now out of this, let's say 15,000 USD, the insurance company will pay, insurance provider will pay, and 5,000 USD the patient has to pay, right? So, or otherwise, might be insurance company will pay the entire amount, or the patient will pay the entire amount. It can be various scenarios based on the insurance policies and all. That's why it's important to know the details of the patient, that what insurance that person hold and all of that. So it starts with a patient visit where the patient details were collected by the hospital or the, we could say, the provider. Okay. Now second step is what? Hospital will provide the services. Services are provided, right? So the doctor provides treatment and the hospital keeps a record of everything done. That is the tests, the procedures, the medications. So that means all the services are provided by the doctors and hospitals. Okay, that's good. Third thing, what happened? The billing happens. The billing happens. Okay. In the billing, what exactly will happen? The hospital create a bill. I'll write, the hospital will create a bill, right? Uh, for the services provided and send it to the patient insurance company to request for the payment. So they will create a bill and will send it to the insurance company if they are about to pay, or if there is no insurance, then the patient will pay whatever. So they will create a bill and will give it to the patient or the insurance company. Fourth, what will happen after this? In this thing process, claims are reviewed. So if this goes to the insurance provider, the claims are reviewed, right? The claims are reviewed. That means the insurance company review the bill. Insurance company review the bill or invoice, whatever it is, to make sure it follows their rules. Because insurance company also has certain norms that how much they can pay, what surgery it was, and they have lot of rules and regulations. So it will see that whether it's following their rules or not. So sometimes they approve the payment, but other times they might reject or deny it due to whatever errors or uncovered services. So they might pay full. So they might accept it, or that means pay in full or partial or decline, whatever, based on whatever policies they have or whatever the insurance policy person holds, right? Now, after this, what happens? The payments and follow ups will happen. Payments and follow-ups. That means once the insurance pays its share, the hospital may bill the patient for remaining amount. That means it might happen that insurance company pay a certain amount and the patient pays for a certain amount. So that will happen that once the insurance company pay its share, the remaining will be asked from the patient itself. And if payments are delayed or denied, the hospital follow up for the issues, right? The hospital will follow up to the patient for the payment, right? So I hope you can understand that uh, if the uh, if partial payment is done by insurance company, or let's say no payment or partial payment is done by insurance company, then some portion or full portion will be given by the patient. Then some portion or complete thing, whatever is the case, is given by the patient, and the hospitals will follow. And the hospital, that means technically we say the providers, will follow follow up for the payment. That's what the follow up means. And then what will happen after this? Tracking and improvement. Tracking and improvement. What does that mean? So hospitals constantly monitor the process to ensure they are collecting payments efficiently and reducing mistakes like declined claims and all, right? So they do not want to lose business. So they want to make sure they collect all the amount. It's not that some patient become defaulter, they are not paying and so on, right? So they want to track it properly, follow up properly, and want to improve the process in case if they feel they are losing money and all, right? So this is how the process is, and people from healthcare background would be aware, but I want to give you a context because some of you will not be from healthcare background, right? So in a nutshell, if I have to say, rcm ensures rcm ensures the hospital can provide quality care while also staying financially healthy financially healthy, right? That means financially healthy in the sense it should not happen that they mismanage things and the patient has to pay, but that patient is not paying and all, right? They are not following up. So rcm ensures that the hospital stays financially healthy so that they can pay to their doctors, they can pay for instruments and all of that, right? That's the whole purpose about rcm. So I hope this is clear. So it's about making sure everyone, patients, insurers, right, and the providers, that means the doctors and all, gets paid on time, or whatever payment they have to do, that's collected on time. So basically, as part of RCM, we have two main aspects, right? We have two main aspects. Number one, we have accounts receivable. That means the payment that hospitals have to take. Accounts receivable, right? Also called as AR. That means the money that they have to collect from the patient or the insurance company, whatever. And then second is accounts payable. That means whatever they have to pay to their doctors, their staff, and the instrument, whatever they have to pay, right? But most important component among this is accounts receivable, and whatever we will be doing in this project will be towards accounts receivable, so that the hospital remains financially healthy, right? There are two parts always, right? Getting money and paying money. So as a hospital, whatever money we are getting, they are getting is accounts receivable. Whatever the money they are paying is accounts payable. So we are more concerned about accounts receivable in this case. So AR is the most important and a key focus area, and the project will be inclined more towards it. Now, in this entire process, you have to understand one thing, that what's the risk factor. What does hospital feel is the risk factor? Is insurance company paying a risk factor? No. Those companies that's dealing a kind of business to business, and that will happen properly. But the risk factor comes when patient has to pay from their pocket. So patient paying paying is often a risk, right? That's a risk. That means if patient has to pay the complete amount or a partial amount, then that's a risk. And if the money does not get collected, then it's kind of a lost business, right? So I'll talk about scenarios when patient has to pay. Scenarios when patient has to pay. See, a case when insurance company pays the entire amount, that's the best for the hospital. Hospitals can even make more money, put make more but higher bills and all, and the money will get paid on time. But the main issue lies when either a customer, or I should not say customer, rather a patient has to pay in full or partial amount. So let's understand the scenarios when patient has to pay. So what generally happens these days, this insurance providers, right? They offer a very fancy schemes saying, oh, now you can get an insurance in this much less amount. But when we talk about low insurance, right? It looks fancy to the patients when they are getting that insurance, but there are a lot of hidden terms and conditions, because when you go with low insurance, right, these people shift most of the burden. These insurance providers uh, put most of the burden on patients itself. That means in their clauses, it will be written that, oh, for this surgery, half of the amount patient will only pay, or there will be certain things which will be deducted, right? All of that. So sometimes we do not have a look, and then we think, oh, we are getting insurance at the low cost, and let's take. So nowadays, because of those kind of insurance, patients have to pay from their pocket, and then that becomes a risk to the hospital, right? I hope this is clear. Now, these low insurance plans are attractive at first, but many consumers don't fully grasp the implications of their deductible until they get the bill. Simple thing. I hope this makes sense to you. Now, there can be some private clinics where, I mean, insurance they won't accept, let's say, right? Or some dental treatment, right? Dental treatments are also very costly, where insurance claims cannot happen, let's say, right? There will be certain insurance policies where deductibles are there, where some things like surgery material and all, gloves and all, the insurance companies do not pay, right? So all of that. So such things are the times when patient has to pay from their pocket, right? So this is the thing. Just have a look of what I have written. So always the thing is, hospitals want to have a healthy accounts receivable here. That's the whole thing, right? They want to They want to make sure they bring the cash, that means collect the money from the customer or the patient. And two objectives for account receivable. Two objectives for accounts receivable, right? That is, first of all, the patient should not default the money, right? That means they should pay. And moreover, it's not just about paying, but they should pay on time, right? So also minimize the collection period. It should not happen that the patient is paying after 5 months, because in 5 months, let's say the money was supposed to be 10,000 USD. After 5 months, as per the inflation, this 10,000 USD will be seen as less, right? So that's a loss to, I mean, that's a loss which you will not directly see, but that's a loss, right? So that's the thing. I hope this makes sense. Now, as per whatever analysis that has been done by some organizations, what they feel is the probability of collecting your full amount decreases with time. That means if you are able to collect early, that's better, because if you're not able to collect in 12 months, then there is no guarantee whether the patient will pay or not, right? So, as per this, whatever stats, 93% of money, right? 93% of money due 30 days old. That means that means whatever is under 30 days old, you will be able to collect 93% of that. 85% of money due 60 days old. That means a hospital will be able to recover approximately 85% of the money which is 60 days old. And as you go beyond 3 months, let's say 73% of money due 90 days old. So this clearly shows that as and when the patient kind of delays the process, the chances of them paying becomes less, right? So I mean, we can always calculate certain metrics in order to see. For example, the metrics or the key performance indicator KPI to measure uh, account receivable and set benchmark I will show you certain things, right? So there are certain key performance indicators or things that you can calculate to understand, is are you having a healthy account receivable or not, right? So I will just tell three of those, but there are many such KPIs, right? Account receivable greater than uh, 90 days, right? I'll tell what exactly that means. I have a link actually. I have a link. I'll just show that to you. This link I'll open. So I have opened this link. You can also check. I will mention it in the description. And I have taken all of this, whatever I am talking from these places. You can see even these numbers, right? Whatever I was mentioning, right? The probability of them paying will become less, right? You see this, 30 days still you can recover, 60 days less, 90 days even lesser, right? And account receivable greater than 90 days, what does that mean? Accounts that have aged over 90 days are at higher risk for going uncollected. You know that, right? That means someone who has not paid for 90 days, there is a chance that they will default, right? Therefore, it's very important to keep track of how much money is moving into this aged category, right? Month on month. So, greater than 90 days equal to account receivable greater than 90 days. That means how much money is there which is sitting in this bucket which is older than 90 days versus how much total account receivable. That means, let's say, you have to collect let's say a million 1 million USD, right? Total account receivable for all accounts is 1 million USD, just an example. And out of that, there is 100,000 USD, which is older than older than older than I would say 90 days, right? Then what does that mean? That means 100K divided by 1 million into 100, right? That's the percentage, which is 10%. 10% of your total money which is pending is older than 90 days, right? So your account receivable greater than 90 days become 10%. You can see this. I hope this you will understand. You can check a lot, right? So there are a lot of such key metrics like this. I hope this is clear. And days in account receivable. Let's say I'll talk about another matrix, days in account receivable. So uh, consider, let's say, so I mean, here, let's say you set 10% benchmark, and now you see that, let's say, your 200 USD is older than 90 days. That means if 200K, that means 20%. But your benchmark set was 10%. So you will check with your team what's happening, why it's going wrong. So this kind of metrics, that's why it's very, very important, so that account receivable is proper, healthy. Now, days in account receivable, what does that mean? Let's say you have your hospital has collected or raised bills of around, I would say, let's say, 1 million USD in 100 days, last 100 days, right? So 1 million USD divided by 100 days, that means per day the collection is 10,000 USD, right? Per day the collection will be 10,000 USD if I see that on an average, right? Now if you see that your total account receivable, the money which you have to get is, let's say, I would say, let's say, uh, 40 or 400,000 USD. That means if 400,000 USD is account receivable, the money which you are about to get, that means it's a money which you have generated in 40 days, right? So the it is 40, this AR, days in AR is 40 days, right? Days in AR, because per day collection is 10,000 and 40,000 USD, right? 40,000 USD is pending. Just have a look. 400,000, sorry, 400,000 USD is pending. So it is something which your hospital would earn in 40 days. So 40 days worth of money is pending, right? So you can set a benchmark. Let's say if this is AR is under 45 days, then it's fine. But if it goes more, then we will just check our processes, are that fine or not, right? So this ways there are a lot of KPIs, right? You can check that out. If you see this days in AR, net collection rate, right? You can see multiple things, that okay, you have to collect, let's say, 1 lakh or 1 million USD, and you are able to collect almost zero point 0.99 million USD. That means around 1%, it went in a way that people are not paying it, it's gone as bad, right? So that means your account receivable or net collection rate is 99%. So that is good. So you can have set your benchmarks here, and there are many other metrics which you can see. So you can check this document, very, very interesting document, and this will give you a clear idea on what benchmarks you can set, what kind of KPIs you can have in the end in order to make this process strong. And there is another link also. I will also keep this as part of your description of the video. These two are very, very informative documents. I have collected all this information from here. So you can see all these KPIs are mentioned. You can have a look and you will get more about the domain. So that's about the entire domain which I would have to say, right? I hope this makes sense. I'll close these documents now. I'll close these documents. Now you should be good, and you would have understood about the domain clearly, right? Now, as a data engineer, what do we have to do? What do we have to do? What do we have to do as a data engineer? We said we will be building a data engineering project. So, as a data engineer, what role are we going to play in this? That's what we have to understand. So we will have we will have data in various sources. And what data I will show you shortly. I will show you that data shortly, but we will have data in various sources. Now, as a data engineer, we need to create a pipeline. Data engineers create a pipeline, right? So, as a data engineer, we would be creating a pipeline. What that pipeline will do? This pipeline we will create so that we end up creating facts and dimension table at the end. The result of this pipeline, I'm not talking about what we will do in this pipeline, but the end result of this data engineering pipeline will be fact tables and dimension tables. Fact tables and dimension tables. And these facts and dimensions will help the reporting team, people who is doing the analysis and reporting, working on visualization. Those people can take these fact tables and can create reports and generate these KPIs, right? Will help the reporting team to generate the KPIs. Just like I have mentioned, you remember some of the KPIs, account receivable, which are more than 90 days pending. That means you will say 20% of my money which is pending for the hospital is more than 90 days old, right? So you would have set up a certain benchmark, but how do you calculate that 20%? Using this, whatever tables we will generate in the end as part of this entire pipeline, right? So all these KPIs can be calculated from this final tables that we will have. So basically, as a data engineer, we need to enable the reporting team so that they can take these tables and do whatever stuff in order to get the KPIs right. Right? So let me now talk about the data sets that we will have. So we have EMR data, right? So I will talk about the kinds of data, right? EMR data, claims data, and then we have the NPI NPI data, and then we have ICD codes, right? ICD data, I would say, right? I will show all of that to you. So EMR data is very very important. Which is, what is EMR? I mean, in case if you are aware of AWS tag, do not think that it is Elastic Map Reduce, right? So this is a domain related thing, and it stands for electronic electronic medical records, right? So nowadays everything is digitalized. So whenever you go to a hospital, right, for the first time, your details will be stored in a patient's table, right? Doctor's detail will be stored in a. So I'll write it. So in EMR data, you have multiple tables. So we have, let's say, patient's table, where the patient details are stored. Then we have providers table. Always remember, providers is the doctor, right? So doctors data will be stored in this, that what doctor and in which this doctor is specialized. All the doctor related details are there in provider table. And then we have department. So every hospital will have certain departments like ortho, or apart from that, dermatology, whatever, right? And then we have transactions table. Transactions transactions is, I would say, so there are two things: encounter and transaction. I'll explain you. Let's say you are having a viral fever and you go to a hospital, let's say, right? Then it's a encounter they will mark, right? That means the uh, uh, first time you visit the hospital for that particular thing, for this new thing that has happened, that's an encounter, and they will associate you with a doctor, and also that's the encounter. Now, for that encounter, right, for that encounter, uh, there can be multiple transactions, that you pay the doctor fee, you pay for the medicines, right? So there can be multiple transactions related to that encounter, right? And that means whenever you go to hospital, they give you a file, right, for that particular thing, and then they keep on I mean, adding to that file, let's say you showed to a doctor today, tomorrow also you are showing, then the file is the same. So that thing, it as a one encounter, right? Even though you go for 3 continuous days, it's just one encounter, but there can be multiple transactions associated. You might be paying for, let's say, physiotherapy, for some medicines, for consultation. There can be various transactions involved, right? So encounter is one for that particular case. Transactions can be many. And other tables you understood: patient, provider, department, right? I will show all of these tables also to you shortly. So all of this EMR data is stored in a database. All of this EMR data will be stored in a database. In our case, we will assume that this is stored in Azure SQL DB. Azure SQL DB, right? And I will show you these tables now before we proceed. So I will go to my Azure account. You can create a free trial account or paid account. If you use it wisely, you will not spend much. I have created a database, Trendytech Hospital A, Azure SQL DB, right? SQL database. Now let me connect to this. I will say query editor, and I will just connect to this. So this will be connected. Let's wait until we are connected to this database. I want to show you what tables we have. So basically, this is a EMR database, right? Where electronic medical records are stored, and these 5 tables. So data will be stored in form of these 5 tables: patient-related data, doctor-related data, transactions, encounters, and department. So now, I mean, before it loads, uh, think of it: which tables will be bigger, which will be smaller. Patients table, there will be new patients, so this can still be a decent size. Providers will be a very small table because there will be hardly few doctors in a hospital. Department will be a very small table because there will be few departments only. Transactions will be a huge table. Encounter will also be a huge table. So the biggest table among this will be transactions idly, and the second biggest would be encounter, I would say. Then patient, and of course this provider and departments are smaller, right? So one patient over the year can have many encounters, right? That means this person might have fallen sick 2 times, so 2 new files would be created for that person, right? But in each time, that person would have done multiple transactions, whatever, right? For this medicine, for this physiotherapy, consultation, whatever it is. Okay, so we are now logged in. I already have these tables, right? Think that this is at the hospital end, and we have 5 tables: department, encounter, patient, provider, and transaction. Now I will show you the data. I'll show you the data. So let me show you for department. It's very simple. Department will not be much. Department ID and the department name: emergency, cardiology, neurology, whatever, right? Encounters. Uh, so before encounter, I will show you patient, the smaller tables relatively. So we have patient ID, first name, last name. This is a sample generated data, by the way, right? Middle name and SSN number, just like we have Aadhaar and all, right? Same way, a unique number for a patient. Phone number, gender, date of birth, and the address of the person. And when this record was modified, might be the address changes and all, right? So this record will be modified then. Then we have provider, that means the doctors. Provider ID, the doctor ID, it means first name, last name, the specialization of the doctor, the department for this which this doctor works, and the NPI. So NPI is basically a national provider identifier, which is a 10-digit number, right? That uniquely identifies healthcare providers in US, right? So this is a unique identifier for each doctor, right? And we can get it through a public API also. So NPI is a number which uniquely identifies each doctor. Okay. Then let me show you encounter id, patient id, right? Of course, because for which patient this file number is, right? Encounter date, inpatient. So there are various encounter type: inpatient, outpatient. So basically one of them is when the patient has to stay within the hospital for night, right? Like they take a bed and all. And one is when they visit and they come and visit on the same day, right? So inpatient, outpatient, and routine checkup. Telemedicine means a phone call, right? Routine checkup means person comes who comes regularly, just randomly they are coming. They do not have any issues, but they are just coming. Emergency, right? All of that you can see. Different encounter types. That why this person has come. Provider ID, that means to which doctor they have been. That means first time when you, let's say, have a fever and you visit a hospital, which doctor, I mean, they have suggested, and to which doctor you are going to show. That's the provider ID. Department ID, that means to which department you are showing, right? Let's say general physician, right? uh, and doctor name, and the procedure, what will happen, and the date on which this record is inserted. That's encounter. Now transaction. So transaction ID, transactions is related to encounter. So for one encounter, there can be multiple transactions, right? And of course, the encounter is related to a patient, provider ID, department ID, the doctor involved, department, the visit date, right? So let's say you visit today, right? And the service can be the same day or next day. See, these dates are messed up because the data was created and these dates are messed up. Ideally, the service date should be equal to visit date or after, right? It cannot be before. In this case, you see before, so that's wrong data generated. But think it that service dates has to be equal to visit date or after visit date, and the paid date also is same, visit date or after that, right? On which date this transaction is paid. The visit type, was it a routine visit or emergency visit, follow up visit, whatever. Amount, right? Total amount for the bill, the paid amount, how much they have paid, right? Amount type, right? So whether insurance company is paying, co-pay means insurance is also paying and the patient is also paying, right? Both are paying some amount, right? Partial amount. Medicare and Medicare and Medicaid, right? There are two different things. These means, so just like in India, we have government some yojana, right, where they say 5 lakh scheme from government side. Same way in US also, it is Medicare and Medicaid. One of them through the central agency, one of them through state agency, right? So that's what these are different through government, central government or state government, right? And the claim ID, payer ID, procedure code, ICD code, right? So, I mean, this ICD code basically it can be mapped to the description of it. That means this code would mean some of the code, let's say it means that okay, this is, let's say, a typhoid, right? So later this ICD code we can pull the data from a API, and then this can be mapped to a particular description of disease, that okay, what exactly is the disease, type of disease, right? I hope this is clear. So ICD codes are a standardized system used by healthcare providers to classify all of this, right? So based on this code, we will understand that what disease it is. So we will see that how we will map to the actual disease, right? Line of business, Medicaid ID, Medicare ID, right? If person is holding any of this, right, government IDs, then that, and the time when this record came. So I have given you some idea about these tables so that you understand what kind of data we have as part of EMR. Now, interesting thing, there are two databases. So EMR data, let's say if you are from India who is watching this video, then you understand that if you're staying in Bangalore, there is a chain of hospitals called as Manipal Hospital, right? Hospital. Now, let's say they initially have one hospital here in Bangalore, then they would have second hospital, then they would have third, then they would acquire, let's say, something else. I know recently they acquired a hospital called as Columbia Asia, right? So that will also come under them. Now, what if, let's say, this Manipal hospital have slightly different table structures? These five tables they have, but they have different column names and all structures. And now, when they acquired Columbia Asia, their patients, the patient details from Columbia Asia will also be now associated with Manipal Hospital. Now, there can be chance that this patient's table has different number of columns, or the column names are different, or more interestingly, what can even happen, let's say, if I show you this, if I show you the data for patients, right? Let's say we have this patient ID. Now consider somehow the patient IDs for Columbia Asia and Manipal Hospital were same, like it was 101. Now, how you will identify what is that? So, how you will try to build a common data model later, so that you try to uh, 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 you should not face these difficulties, that how do you merge these two schemas together, because they might be using different column names, or if they are using same column names, might be they are using the same patient IDs. Then how will you know which patient ID is coming from hospital A and which coming from hospital B if the patient ID is the same, right? So we would, that's where I am taking two hospitals to showcase a common data model later. So we will be taking hospital A and hospital B. Hospital B. Think that there are two different branches of a hospital in Bangalore, right? But they have slightly different schemas for some of the tables, and some of them have like same patient IDs. Then we would implement a surrogate key later, so that we are not dependent on that, right? So we would implement a common data model later. That's important thing. That's why I have taken this scenario. So that's where, if you see, if I go back now, if I go back, if I go to home, you see I have two different databases: Trendy Tech Hospital A and Trendy Tech Hospital B. And this hospital B has same number of tables, but I will slightly modify the schema, so that later I show that how we merge these two, so that we do not face any difficulties later, right? So this also has same number of tables. I will just show you quickly. I'll quickly connect. This is going to be really really interesting, right? Because that's how things work in industry. I mean, if I give you a dummy idea, then it will not suffice your purpose. So let's say this, all these tables are there and some data is there. Some data is there. You can see. I hope you can understand that. So we are good with both these. We are good with this EMR data, and we understand there are two different databases. So hospital A data is stored in a different database, right? Which is Trenditech Hospital A, Trenditech Hospital A, and this will be in Trenditech Hospital B. Two different databases are there. That means two different instances of Azure SQL DB, right? Both of them have five tables. So that's my EMR data, which is very, very important data. Now this will be in the form of tables, as you understand. Now other kind of data will be claims data, which your insurance team will send. Insurance company or the payer, we say them as payers generally. The payer will be sending us this data, and they will upload in the form of flat files. They will upload in the form of flat files, and they will put it, let's say, in our specified container or specified folder in our data lake, right? So what we have done is, we have created a data lake, we have created a storage account, TrendyTech ADLS dev. You see a normal storage account. You can create. I'm not creating instant things here, because if I create, it will take too long. These are simple things. right? I expect that you know some level of uh, Azure cloud so that you can create these instances at least, right? So TTADLS dev. Now I go to containers, and here there will be a folder called as landing, right? Do not worry about other folders. So there will be a folder called as landing. In this, these files will be uploaded by the insurance company, and for each hospital they will upload, right? I will just show how it looks like. A CSV file, flat file. That's why I say as a flat file, it's a CSV. So the claim, right? Claim ID, transaction ID, patient ID, encounter ID, provider ID, department, service date, claim date, payer, right? And claim amount, paid amount, claim status, right? I'll talk more about this, but you understand that this is related to the insurance, that have they approved, if approved, how much amount, and so on, right? So we have this data which will come in the form of flat files, and this you think that they will send it monthly once. So till now we have seen two different data sets. One is our EMR data, which is in our database. We have two different databases. That means two different instances of EMR running. And we have claims data, which insurance company will be sending in the form of flat files. They will upload it in a folder, right? What folder I will again show later, but to be at a very high level, landing folder, right? Okay. Now there are two other kind of data that we will be using, and that is NPI data, right? So claims data you understood, flat files which will come from insurance, that is providers. Now NPI data, what is that? National provider data or national provider identifier. So you remember that I mentioned each doctor is given a 10 digit unique code or number, and national provider identifier, right? A unique number that identifies each doctor. And there is a public API available for this. Public API, we can call that and get all the list of doctors from there, along with the NPI, this thing, details. So complete details of doctors, that means the providers is we will get from NPI, this thing, API, public API. I'll show that API also later. You can see this NPI data. How does this look like, right? NPI ID, first name. I have some sample data. First name, last name, position of this person, organization name for which this person is working, last updated when this record was last updated, and is current flag true, right? Like that. So this is more about the provider data, right? I hope this is clear. This is about NPI. Now, in case if I am, see, I am not from healthcare domain. Whatever I could understand, right, I am trying to explain. And if you feel somewhere I am incorrect, then do mention in comments, right? So because let's take it in a very constructive manner so that we all learn, right? So in case if you feel somewhere I am not clear with the domain like NPI and all, you can always feel free to mention in the comments so that everyone can learn, right? But as per my understanding, I am talking about these things, and can be a chance that I'm sure I would be 98% correct, but 2% if there is any issues, you can always mention in the comments so that everyone learns from that, right? So NPI data we have seen, and we have ICD data. What is that? So we have ICD codes, which is nothing but a standardized system used by healthcare to classify. I mean, uh, that means you have a code like this. For example, this is a code, and then we have the description. That means cholera due to whatever, right? For example, this code you see, if someone's diagnosis is this code, that means it is typhoid fever. So we have a API which gives us this kind of mapping. That means the ICD code and description. So we will run these two APIs also to get this data, right? NPI data and ICD data. So I will write ICD codes are a standardized system used by healthcare providers to classify and to basically map diagnosis codes and diagnosis code and description, right? A mapping kind of that you will get from this ICD data. So there is a API for that. There is a API that we will see. But in this particular part one, so as I said, this project I will be having two parts. This is the part one, and in this I will mainly talk about our EMR data. So you kind of understood that we have now EMR data, which is in database, right? We have claims data, which is in form of flat files like CSV, and then we have data coming through APIs, right? Which is nothing but NPI, right? And our ICD data, ICD codes. These are the data sets at a high level that we have, right? So I am sure now you are clear with whatever data sets that we have. So with this, you understood about the data sets very properly. Now, I will talk about the architecture that we will be following in this, right? So, the solution architecture. So, we will be following a medallion architecture, by the way, right? I hope you know what is a medallion architecture. In case if you do not, I will just give you an idea what is medallion architecture. So, what happens in a medallion architecture that let's say let me tell that let's say if you have a landing zone or a landing folder, so just like if you go to our storage account, right? If you go to our storage account, by the way, the storage account that we create, if we turn on this hierarchical this thing on, right? So hierarchical namespace enabled, then it will become a ADLS Gen 2 account. Otherwise, it will be a normal blob storage. So it is recommended to turn that on for big data analytic workloads and all, right? ADLS is quite performant that way. So I have created a storage account, and in that, if I go to containers, you will see there are multiple containers. I have bronze. Ignore that config for now. Bronze, gold, landing, silver. So I'll write landing, bronze, bronze, uh, silver, and gold. Right. So if I have to draw a line or lineage, it would be this way. That what happens first, let's say you have some of your data or all of your data in the landing folder, right? And then you try to move it on the right side. So from landing you move it to bronze, from bronze to silver to gold, and you keep improving on the data in terms of cleaning, in terms of better data and all of that, right? So I'll talk about it. So right now I mentioned what data sets we had: EMR, right, and claims data, right, and then apart from that, codes, right. So we have this data. So EMR was in SQL DB, Azure SQL DB. This was flat files, and this also we can get as form of files and all. Like we can run the API and we will get it, right, in terms of files. Now this we can get in some other format, not flat file. Let's say we can get the data in Parquet format using the APIs. Let's assume that, right? I have to check, but let's assume. So now in your landing, if I show you this landing, they will the insurance provider will be putting these files here, right? Insurance provider will be putting the files in landing. So that's fine, that are flat files. Now, so in landing you have insurance files, But what about this EMR data? EMR data is in database, and now when you bring it or when you try to load it, you will directly bring it to your bronze layer. This landing zone will not be coming into play. So landing zone is only when the data is in form of flat files. So if it is in the form of flat files, we are keeping here flat files initially, right? And then uh, in my bronze layer, I will keep it in the form of parquet files, right? Parquet files. And in my silver layer, I will create delta tables. I'll create delta tables. I'll explain more, right? In layer, I will create delta tables, and in gold layer also there will be delta tables. Delta tables, right? Databricks delta tables that way. So not necessarily everything will be in lending, right? So the insurance company loads something in lending in form of flat file CSV and all, then we take it to bronze to silver to gold. But this EMR data, it will directly, when we load it, how we will bring it, we will ingest it through Azure Data Factory, and then when we do it, we will directly bring it to bronze layer in the form of Parquet files, right? So bronze layer will hold everything in the form of Parquet files. And when we get this codes and all, when we run the API, we can directly get it to bronze layer. So lending zone is only for insurance data in our case. Otherwise, uh, the EMR data which we get from tables and the codes like ICD code and NPI, we directly get it to bronze layer in form of Parquet files, right? And then we take it to silver. What we do from bronze to silver, we basically, I will write it. I'll write. So bronze has Parquet format, is in Parquet format, and you can think it like source of truth. Source of truth. That means if sometime you have confusion in silver and gold, and you want to go back to the actual data, you go back to bronze layer. Now, talking about silver, from bronze to silver, what changes? Basically, we do data cleaning. While loading to silver, before loading it to silver, we do some cleaning of data, cleaning of nulls, and data quality checks. We might enrich the data. I'm talking in a general sense. We might enrich the data by joining it with something and all, right? Now, in our case, we will also implement a common data model because we know we have data from two different hospitals, and we will assume that patients table have different column names and the patient ID might be similar. So we will implement a surrogate key so that we can properly merge these two databases without any problems, right? So we will implement a common data model. So before loading to silver, we will implement a common data model, right? CDM. Also, the we know that okay, the patient detail can change, right? That means the address can change, the doctor details can change, and so on. So we will implement a SCD type 2 so that we maintain the history also. So you know that we have different kind of slowly changing dimension. For example, in our case, a patient table, provider table, all of these are dimension tables, right? Kind of. So the things can change and we can end at the previous record and the new record will come. So we maintain the history. We will talk about SCD type 2. So we even implement SCD type 2 so that we maintain the history. So that's our silver layer, right? And once the data is in silver layer, data is cleaned, enriched. It is, it follows a common data model, and it has previous history also, right? Using SCD type 2. Then final is gold layer. Gold layer. In gold layer, gold layer is basically we, if there is any aggregation to perform, we can do that. But in our case, what we will be doing, not aggregation, but aggregation is more in a general sense, I am saying. But now, what we do, finally, we want the answer in the form of facts and dimension, fact table and dimension table. so that my reporting team can build their KPIs, right? Can understand all of that metrics. So I need to build the right data model for facts and dimension, and I will show you how exactly we build that, right? And my reporting team will take this and can whatever build reports on top of it. So I hope this is clear. And you see, the more you go on the right side, the better you have the data. And each of these layers serve different personas or different kind of person. If you ask me who will be the end user for gold, I would say business users. Business users who have to take business related decisions, right? Gold layer. Now, who will be using data from silver layer? It's more clean data. So basically, if there is a data science team, right, data scientists can use machine learning experts, right, or even data analysts, because they need still the granular level data, right? They do not need aggregated data as in gold, but they would need granular data, but they need clean data, right? So each layer serve different personas or help different kind of persons. Now, bronze layer is for whom? I would say bronze layer has raw data as such, source of truth. So ideally a data engineer who can implement whatever they want, right? Each layer serves different personas in the medallion architecture. Now I have mentioned three layers. Sometimes people might say instead of bronze raw layer, and they can have 4 or 5 layers, but each layer would serve a different use case, right? So there is no hard and fast rule that there can be only 3 layers in this and so on. In our case, landing folder, if anything is there in landing folder, that will be flat files. In my bronze, I will have Parquet files, right? I do not have tables still in bronze. And from silver layer onwards, I will create delta tables, Databricks delta table, right? From this layer onwards, I will have tables. I hope we are good with this. Now, I will show you how exactly this high level architecture looks like, right? So you see this. We have hospital A, Azure SQL DB, hospital B, Azure SQL DB, two databases. Again, we have a folder like a container in our ADLS Gen 2, which is our data lake, right? Where we get the files from the payer. Payer is nothing but your insurance company. And we have public APIs, ICD code and NPI, whatever, right? This public APIs. Now, from the databases, EMR data, directly when we get the data, how we will get through Azure Data Factory. Azure Data Factory is for data ingestion, right? We can use Azure Data Factory for data ingestion, and this data will directly come in the bronze layer, and then it will come in the form of Parquet files. That means we take the data from databases, put it in our bronze layer, bronze folder in the form of Parquet files. It will not be there in landing. Now, pair files. Let's say we have given the access to the insurance company for the folder, landing folder. They will dump flat files in CSV format every month, right? So data is in CSV. We take the data from landing folder CSV format, put it in bronze, and convert it to Parquet, right? Again, we do this using our whatever we can do through Databricks or Azure Data Factory, whatever. We will talk about it later. Right now, I'm in this part one. I am interested in only my EMR data, and then this public APIs we call through Databricks notebooks, and we again get it into bronze. So anything that we can get it directly in Parquet, we will put in bronze. We will skip the landing layer. Now, in bronze, everything is in my Parquet format, right? Everything is in my Parquet format. Now, next is I take this data from my bronze layer, this folder, and I clean it. I implement a common data model. I implement slowly changing dimension, and then I put it in silver layer. But now it's not in the files, rather, it's in a delta table, right? Delta table where we can even write, perform acid transactions and so on, right? We'll talk more about it once we see that in the later part, but that's how it is. And then in gold layer we create facts and dimensions. So this is how I do. And the major technologies that will be used will be your Azure Data Factory and Azure Data Bricks, right? So there will be a heavy role to move from bronze to silver, silver to gold using Databricks notebooks, right? So most of the logic will be in Databricks then, right? So if you ask me, sir, many people ask me, Sumit, sir, what are the most important technologies that we should be knowing in Azure cloud? I would say Azure Databricks and Azure Data Factory, and these two are the two heaviest portions of this project, the best part about it. But we are using more technologies. We are using Azure SQL DB. We are using our Azure storage account ADLS Gen 2, right? And we are using the APIs, whatever. So we are using various things here. I hope this is clear. And towards the end, what's our end goal as a data engineer? Do we have to do visualization? No. Or reporting? No. Our end goal is create facts and dimensions so that my reporting team can take care, and that will be in gold layer, right? So in gold layer, we have to generate facts and dimension. I want to show you the ERD diagram for that, right? So at a high level, this might have slight changes, but at a high level, this will be the thing. We will have a lot of dimensions. Patient is dimension, diagnosis is dimension. So fact is what? Fact is nothing but a fact, like a transaction, right? And any supporting, let's say, my name is Sumit. I purchased a laptop for $1,000, right? Which is a MacBook. I purchased it from a store in Bangalore, let's say Indranagar. Now, the actual fact here is the amount, that is, I purchased something for $1,000, right? That's the amount. I purchased two quantities. That's the fact. So, fact is nothing but numeric things like amount, number of quantities I purchased, and so on. And any supporting thing like who purchased, when they purchased, from which store they purchased, who was the seller, right? All of that. Those are additional information for the transaction. Those are dimensions, right? So those are dimensions. And dimensions might change slowly. I'll write it. I'll write it. So if I want to get talk at a very high level, facts and dimension. Facts is nothing but a fact which is a truth, right? Something that has happened, a numeric value. Numeric value. Now, do not say, Sumit sir, employee ID is also numeric value. It should be a fact. No, right? So, ideally, a numeric value like total amount, right? Total quantities, all of this can be facts. So, anything which is a numeric value or a decimal point is a good candidate to be a fact. But dimension is all the supporting things, right? Supporting things. A fact never change, right? But a dimension can change, and that's where we have to implement SCD type 2 to maintain history. We have different types to implement this, right? SCD1 where we do not maintain history, we override it. SCD2 where we maintain history, and SCD2 is what is a industry practice. So anyways, I will close this diagram. We have understood this. uh, this one I was showing. So we have a transaction, fact transaction, right, which is nothing but the fact, and it has a lot of references to the dimensions you see. So patient ID, we have patient's dimension. Department ID, we have department dimension. Provider ID, we have provider dimension, that is doctor, right? And then ICD code, we have right, this code dimension, right? Encounter ID, claim ID, right? So a lot of this references are there, but we have payer paid amount. These are actual facts. Adjustment amount, patient paid amount, all of this, right? So these are facts. So you can see even this dimensions have link. For example, you see this dim department has a link to dim provider, because a doctor can be in a certain department. We could have clubbed these two, but if we separate, then it's more like a snowflake kind of style where I mean we would have to join these two also, right? Because these dimensions can also relate to each other. Otherwise, if you go with the normal facts and dimension, then a fact can be connected to a dimension. A dimension cannot be related to another dimension. But if a dimension relate to another dimension, that's more like a snowflake style schema, right? So this is what we want to build at a high level. This might have few changes, but at a high level, our understanding is we want to build facts and dimensions after doing all the cleaning, implementing a slowly changing dimension, implementing a common data model. In the end, our end result is this, so that my reporting team can take this and build their reports and all on top of it. I hope we are good. So with this, you would have a lot of clarity now on what exactly we are aiming for. Now, what we have to do is we have to implement the solution, right? So what in this part I will talk about EMR data only. That how to bring the EMR data to my bronze layer. That's the thing I will talk about. And now you might think it's a very easy thing. It can be easy, but the way we will solve it is in a more industry related fashion where we create a generic pipeline. Very, very important. Right? We will create a generic pipeline and you will see how beautiful things will flow. Right? So I want to bring this EMR data to my bronze layer. That's what I would show you now. So now the technologies that we will be using will be Azure Data Factory. For what? What do we use Azure Data Factory? For basically ingestion, because we will get the EMR data through Azure Data Factory, right? And we will put it in our data lake, which is ADLS Gen 2. I'll talk more about it. Anyways, that's the main part. And then we will be using in this project Azure Databricks. So Azure Data Factory and Databricks will be heavily used. We are using Azure SQL DB, and we are using, or we will be using Azure Storage Account, right? And we will be using Key Vault also, not now but later, for storing our passwords and all of that credentials, keys, right? Which is a good thing. So our raw files or Parquet files, all of that, our data will be stored in the storage account here, right? Uh, Raw files or Parquet files, and then Key Vault for storing the credentials so that it does not get leaked, right? And Azure SQL DB is where our EMR is there. We will also create one or two more tables just for our reference. And Azure Databricks is for our data processing, right? That is our ETL, whatever we do, moving it from bronze to silver, all of that, cleaning, implementing a CDM, SCD type 2, all of that will be done through Azure Databricks, right? And we might use more technologies, but at a high level, I just want to give you an idea that this is the stuff. And Data Factory and Databricks are the two most important components that are there, right? Now, first thing that we have to do is we have to create a Azure storage account, right? And in our case, we have created a Azure storage account with the name TTADLS Dev. TTADLS Dev. That's the storage account name. Now we have made it hierarchical namespace so that it becomes a ADLS Gen 2 account, right? ADLS Gen 2, which is preferred for our data analytics workloads or bigger workloads, optimized for those, right? So this we have created. If you see here, if I come on this, so you see hierarchical namespace. So when creating, you just have to check that option of hierarchical namespace and it will become your ADLS Gen 2 account. Otherwise, it will be a normal blob storage. Fine. Now inside this, we have to create containers, right? You click here and create containers. I'm not creating here because it will take a lot of time just to create. So the containers that you have to create are, I'll just mention the hierarchy because you can do the same. You have to create a landing container, bronze, silver, and gold to implement your medallion architecture, right? So you see all of those four folders are there. But apart from that, I have one more folder which is called as configs, which has nothing to do with I mean, with this four. For my medallion architecture, I have these four. Configs is for me to keep some configuration files. So you see, lending, bronze, silver, gold. Configs is for me different, not a part of medallion as such. Right? Now, I want to keep some configuration so that I implement a generalized pipeline, a generic pipeline, or a metadata driven pipeline. I want to create a metadata driven pipeline, right? Which is something which we should be doing, right? That's where I want to have this configs folder. And inside this, I will create a folder called as EMR because I want to create a generic pipeline for EMR data. So I will go to configs, where is that? Yeah, and EMR. I have created a folder. You can add directory. I have clicked on add directory and created EMR directory, right? You see this. Under configs, I have EMR. So configs is the container inside this EMR directory. Now I will have my config file, which is loadconfig.csv. Inside this folder, I have load config.csv, right? I will show you that. I'll show you this file, and we have this stuff, right? So in this file, I have this. That means database, right? You will understand why these columns, but at a high level, I will explain you. First column is database. That means whether it is Trenditech Hospital A or Trenditech Hospital B. We have two databases, right, in Azure SQL DB, right? The second column is data source, right? Whether the source is hospital A or hospital B. I mean, this we will use it later. That's why we have, right? This we have created newly a new column that way. Table name. Now we have five tables in our database A and five tables in hospital B, like that, right? So this is database A and this is database B. So five tables here, the first five. So you see, we have DBO. DBO is nothing but the schema, right? In the Azure SQL DB, just like we have app schema, DBO, we can have various schemas, right? So DBO dot encounters. DBO is a default schema, right? In Azure SQL DB. So encounters, table, patients, transactions, providers, department. Five tables. And then we are talking how we want to load it. Is it an incremental load or full load? So load type is another column that we want to specify, incremental or full, right? So if incremental, then it will see this and do a incremental load. That means it won't redo the work what it has done earlier. If 100 records are loaded previously, two new records have come, only two will be taken care. So any transactional table like transaction or encounter, right? Or even like transaction encounter, mainly these two should be definitely incremental because these will be having a lot of data. These are more like your fact tables, right? So you see encounter and transactions. Even patients will be a bigger table, so we can have it incremental only. The provider, which is hardly 20, 30 doctors and 5, 6 departments, this can be full load because this is very less data, right? So this load type is incremental or full. Now watermark. So if it is a incremental table, that means if we have to load the data incrementally, then we have to define a watermark column. That means based on what column we perform that incremental load, right? Based on what column. So watermark column will be applicable for incremental only. So for incremental, here we have modified date. That means any new records after this particular modified date, we consider as new data. So we store the last modified date here, and any new records we'll pick after that. So that is our watermark. So for incremental, modified date here, and if it is a full load, then no need for a watermark column because we do not have to perform incremental. So only when performing incremental, watermark column will come into picture, right? Based on which our incremental strategy will be taken care. Now is active. This is a flag where if we make it zero, we say that my pipeline should not, when I invoke this, this particular table should not be ingested. That means this is inactive. That means it should not run for this. When I make it zero, that means this is not active pipeline, right? Zero means inactive, one means active. So only the records with one should be taken care. As part of my part one, I have not implemented that, but as part of part two, we will do that, right? So sometimes it happens that you do not really want to run your pipeline for some specific tables for some reason, then you will put mark it as zero. That means you will make it as inactive, right? So this is called as a metadata driven architecture or pipeline, right? And the target path you will understand why we have put, because we'll be putting it to some folders, either a hospital A or hospital B accordingly, right? So you will understand target path, data source, right? That why we have put this. But these configurations we have put so that after reading this, the system knows what to do and how to do, right? So we have this particular file in our config.csv, and where we have loaded under configs EMR folder, load config.csv. I hope this is clear, right? So this is about our this particular folder. So bronze, silver, gold, landing, and configs. Everything is clear, I believe. Okay. So now let's come to the most important part now. Let's come to the most important part where we have to implement the pipeline. And the pipeline is what we want. We want to take the data from EMR, that is our Azure SQL DB, and we want to load where? Where we want to load? In our ADLS Gen 2. That means we want to configure or set our data lake, right? That means we want to bring it to a data lake. In what folder? In bronze folder, in form of Parquet we want to bring, right? In form of Parquet format. I hope you can acknowledge this part, that we want to take the data from database and bring it in bronze folder in Parquet format. Bronze folder in Parquet format, right? That's what we want. So we have to create a Azure Data Factory or ADF pipeline for this. So now when creating or configuring a ADF pipeline to ingest the data, there are few components of a ADF pipeline. You remember, in case if you know, link service, right? Then we have data sets, and then we have certain activities, right? And then we create the pipeline. I'll explain all of this. I'll explain all of this to you, right? So, linked service and what it is. Linked service. So, what linked service is? Linked service is basically, let's say you have to get the data from SQL database, right? So, you need some connection parameters in order to get the data from there, right? No one randomly can connect to my Azure SQL database, right? There should be some connection string or connection parameters in order to connect to it. So link service says that how do you connect to your source and how do you connect to your target. So we would need link service for the source, we would need link service for the target. So in this case, I want to connect to my Azure SQL DB. So I need a link service for my Azure SQL DB so that I can connect to it, right? And I need another link service to put my data to ADLS Gen 2, the target. So I need another link service for my ADLS generation 2, right? This is for my source, this is for my target. I need connection parameters, that how do I set that, okay, how do I connect to Azure SQL database? How do I connect to ADLS Gen 2, right? These two are there, right? As of now, I mean there will be more link service, but at a basic level you can understand that these two are definitely required. Now we will also create one audit table, right? I'll write it as part of this pipeline metadata driven architecture. We will create a audit table where whenever the pipeline has run, we will put an entry saying, oh, the pipeline has finished at this time, right? The pipeline has finished at this time, so that we mention the time, so that next time when we run, we try to pull all data after that time. So for our incremental load, that last modified will help us there. So that's where we need such a audit table. I will explain or show you what audit table is, but remember that as soon as our pipeline finishes, we will put an entry to the audit table, and tomorrow we can check, oh, is our pipeline successful or not, what time it has last ran, and all of that. Now, this audit table where I want to create, this will be my delta table. In my Databricks, it will be a delta table. So, if I want to create a delta table and put an entry in that, I need another link service, right? And this link service should connect to what? Should know how to connect to delta, right? Delta lake, right? This should know how to connect to delta tables or delta lake, whatever, right? Whatever you can write. And now going forward, when I would be putting my passwords and credentials in a key vault, then I should be knowing how to connect to key vault, right? So I would be going forward creating a key vault link service also. In this case, in this part, I will not create this, but I would create these three, right? One is to how to connect to Azure SQL database to get my data, how to connect to Azure ADLS Gen 2 to put my data, how to connect to this delta lake in order to create this audit, put entry to a audit table, right? Because is a delta Databricks delta table, right? These three link services I will be creating. Key vault I will be creating in my next part, when I create implement a key vault and all, right? I implement all the things in a better way. So these are link services. So link services is basically a connection string which tells how to connect, right, to a source or a target, whatever it is. Now, another thing that we have, that okay, I am saying, okay, I want to, let's say I'm saying I want to read something from ADLS Gen to my storage account, then I will create a link service. But now I have to say, okay, what is the file name? What is the file path? And let's say the file name, file path, and the file format, right? These things, how will I specify? Using data sets, right? So then we define data set which says, okay, can I know what's the file path, what's the file name, what's the file format, where I have to put, or in which format I have to put the file. I hope you can understand this. In case of your Azure SQL DB, let's say you connect it to the database, then don't you feel then our role is to tell what database name, what table name, the database name, right? When connecting to a database name, table name, schema name, right? All of that. So that is where we define a data set. That means I know that I know how to connect to Azure SQL DB, but inside this, what database, what table, what schema, that is we define as part of the data set. I hope you have got an idea. Mostly you would be aware, but still I'm giving you an idea so that even if you do not know Azure Data Factory, you should be able to understand this in a very layman term, right? Just have a look at this. So we will. So you understood that why do we create data set? So we would need data set for what? Uh, in case of Azure SQL DB, in case of Azure SQL DB, we would have to define a database name, table name, schema name, like that, right? In case of ADLS Gen 2, we would have to define the container name, file format, all of that. I'll just put it in brackets. I want to give you a rough sense of why this, right? Okay. And then after that, so let's say when we are doing for ADLS Gen 2, let's say your format is let's say delimited text, flat files, right? Flat files is delimited text. So you will create a data set for delimited text, right? Which will again be related to this particular link service. So we are saying what data set it will handle? Delimited text. And it will be related to ADLS Gen 2 because either to store the data or to take the data, right? Then if we want to put the data in Parquet format, we can create Parquet data set, right? Parquet. And again, this is related to ADLS Gen 2. This is related to ADLS Gen 2 link service. So basically, you should associate a link service to a data set, right? So in this, when we are defining a Azure SQL DB, then we associate Azure SQL DB link service. When we are defining delimited text, right? Then we define ADLS Gen 2 link service, whether it's a source or target, whatever. Same way, when we define Parquet, we define ADLS Gen 2 link service. And when for this delta lake, right, we define Databricks delta lake dataset for this delta lake link service. I'll show all of that to you. Do not worry. Then it will be more clear, right? So we need to have right data sets. So I will just show you this things. I'll just show you. Uh, so I will go to my Azure Data Factory. I go to Home and I will go to TT Healthcare ADF Dev. That's the ADF I have, right? I will say that that's the ADF instance we are in. I will launch the studio. I've launched the studio, right? And now what I will do, I will go to manage to show you the link services which I have created, right? So now, if you see that we have to get the data from database, Azure SQL DB. So we should be having a link service for that. So here is that link service. Naming convention I will improvise in the part 2. Right now the naming convention can be little weird, but that's fine. So you can see this. Uh, it is to a link service to connect to database, right? And it's always a good practice to say underscore ls towards the end so that by seeing it you understand it's a link service, right? Naming convention I will talk in my part 2. So then what we have, I have defined the fully qualified domain name for this database. So I will just show you. If I go to home and I go to, let's say here, right, I have this server name. I have this server name which I have mentioned. You can see this, the server name, right? Now we have two different databases. We could have easily created two different link services for one for each, but I want to develop things in a generic manner. That means, is there a way that I can just develop one link service and then that link service will help us to connect to both of these databases, EMR databases, the hospital A and hospital B? That's how I have developed. So what we will do is we will generalize it. I will show how to do. You ignore this for now, right? Authentication type, SQL authentication. My username is SQL admin. My password, whatever I have given the password. When I implement a keyword, I will implement a keyword here also. Right now, it's a normal password which I have shown, right? Normal password which I have given that time, right? And if I show here, I have given a parameter here, DB underscore name, because I have two different databases, right? One is hospital A and hospital B, right? Two different instances of Azure SQL DB. So DB underscore name, which is string, and now I will pass this dynamically, right? So you can see here that database name I am saying linked service.db name. That means I'm not passing, I'm saying it we will pass it later. We will pass it later. So I'm saying database name will be basically whatever the value we will give this, but we are not giving the value here. If we would have given some value, my database name would have been taken that way, right? I could have mentioned my database name here, hard coded here, but I am saying no, no, this will be the value of this parameter, and I have not given this parameter because I will be passing it later. I will be passing it later, right? Now later, that means from where I can pass. The wrapper for this would be my data sets. As I mentioned, we have link service, and we connect this link service with the data set. That means when defining a data set, we mention the link service. So we have an option that we can basically define this database name when defining the dataset. And if we do not give it during dataset, then we can do it when defining the pipeline. Because how it goes is, if you think that pipeline is at the top, then we have dataset below, and then uh, we have our link service below, right? So if we are not giving a parameter here, then we can pass that in dataset. If we are not passing here, then we can pass that in pipeline. So if we pass something here, that can flow here, and then that can flow here, right? So that's how it is. So dataset is on top of link service, and pipeline is on top of datasets, right? That's how it is. So right now I have not defined the database name because I want to create a generic one. Otherwise, I would have created two different link services here, which I do not want. Because let's say if there are five different databases. Now, will I implement five different link services? No. It's always better that we pass this dynamically from the pipeline later. And we will see that. I hope this is clear. Keyword we will implement later. So I will just cancel. So you implement, you understood that how to implement this particular link service, because this will act as our source to get the data. So we need to know how to connect to this, right? So we have given the database username, password, right? But to which database to connect, that we will get to know dynamically. Now, now this was our source, right? Now, ADLS Gen 2 is our target where we want to put the data. So we need to create a link service for this also. Whether source or target doesn't matter, but we need to connect somehow. Whether it's a source or target, it's not our concern. So link service is required. So now we have to create a link service for ADLS Gen 2. So let's see. This is the one that is there. So ideally, I could have given it a better name, and it should have been ending with underscore ls, but we will rename it properly in our next part, where we will see best practices and all. So now I have given the name for this authentication type. So basically, if I go to my storage account, right, and I let's say uh, go to access keys here, I can show and copy it from here. This is my access key, right? I have put the same access key here, right? I have put the same storage account key here. And before that, I have to give the name of this, right? This URL. How do I get this URL? I will just show you the overview of this, and let me show you where to get this. So you go to endpoints, and you will get this data lake storage, this one. So you give this URL right here, and you give the storage account key. How do you get storage account key? Again, I am showing you. You go to security networking access keys, and here you click on show, and then you copy that key, right? I'm not showing you because I want to use it later also, but that's how you copy it and paste it here. And then you can test the connection. This should work. This should be successful. because not I mean only authorized person can connect, right? So you see connection successful because we have given the password of it, credentials for it, right? Later we will store this in key vault so that the credentials are secured, right? So no parameters as such here, all good. So we have created these two. So for Azure SQL DB and ADLS Gen 2. Now, once we create, we can use it as source or target. That's okay. Anything is fine. But once you have given the credentials, it's anything you can use. Now we should be creating for Delta Lake also because we will be storing our I mean that audit table and all, right. So Azure Databricks Delta Lake. That's the name I'm giving, Azure Databricks Delta Lake. And what I am doing, uh, so you can see this Azure Databricks Delta Lake. That's one you have to select. So if you see the previous ones, for SQL it is Azure SQL database. So what you have to do, I mean, uh, when creating a new link service, click new Azure SQL database like that. You click and then start configuring. And for ADLS Gen 2, same way you click on ADLS, uh, this one, Azure Data Lake Storage Gen 2, right? So the one, that one is this, right? This is Azure Data Lake Storage Gen 2. You click there and start configuring this way. And now I was showing for Azure Databricks Delta Lake. Now give it some good name, and then now if you have to do that, your Databricks cluster should be on, right? Because you can only create a delta table when your Databricks cluster is on, right? Because this is a delta table that you will be creating. So what I will do, I have, let me go here, home, and I've created a test workspace. Again, not a good name, but right now a test workspace for Databricks. I launch workspace, right? I'm launching this. So the workspace is launched. You can see that I can go to workspaces if I want to see my notebooks and all. I can go to compute to see if any cluster is on or not. So I mean, I initially, I mean, have created a single user, single node cluster, and I use standard F4 which uses 4 cores and 8 GB memory, and terminate after 10 minutes of inactivity, right? So it consumes only 0.5 dbu per hour, the least that I can spend, right? So but make sure you have a termination time and click on terminate after, right? So now let me just start this so that once it starts, then I can I mean have a cluster on. I can show you how we get the cluster ID and so on. Let's confirm. So let's wait for the cluster to be turned up. Okay, so you can see the cluster is turned on. It took around 5 6 minutes in order to do that. Now, since the cluster is turned on, I can go to my workspace. I could have seen the notebooks before also, but I could not have associated it with the cluster to run, right? So now, uh, if you see audit table, just want to give you an idea that what is the audit table that I am talking about. So we have created this particular audit table. Create schema. Uh, so yeah, so if you see, I'll go down actually because I've written it here. So if you see here, we are creating a schema audit. So generally in Databricks, a schema is nothing but like a database, right? Just like we create a retail DB database and all. So consider we are creating audit as one database, and inside that we want to create a table named load underscore logs, right? And in this ID, which is auto increment data source, we are putting that what's the source of data. So if you can now recall, if I go to my storage account, if I go to my storage account and go to containers, and then I go to uh, configs, right? Now, if you see, you can relate that I am saying what is the data source, right? So I will put like hospital A or hospital B, right? Table name. So table name we will put, right, like encounters table or patients table. That which table just completed the pipeline, right? So data source, table name, number of rows copied we'll put like 50 rows copied or something. Watermark column name. So in most of the case it's last modified date, right? And apart from that, load date. That what time this is last loaded, right? What time it is last, the record is last loaded. So this audit table we will create, and how it helps is that you want to see, did my pipeline ran yesterday successfully, you can go to this audit table and check these logs. This will help you a lot, right? So this audit table, we have created load logs, and in this we will be loading the logs after the pipeline succeeds. So if I show you this, we have created this, right? So now to start with, we will basically, the table would be there, but I would truncate this. I'll truncate this. It has truncated so that, I mean, it should not show anything. But if it shows, it will be like auto increment ID, data source, hospital A, hospital B, which table, how many rows copied, and watermark column name. Only in case of the full load, incremental only it will be there, right? For full load, it will not be. And load time, right? Load time. I'll talk more about it, but right now, if I run this, it should not show anything because we have truncated it just now. We have truncated, right? Nothing is shown. Okay. Now we want to create a link service to this, right? That's how we came here, because not a random person can connect, right? There should be a way. So I click on this. I mean, that means if I have to create a link service, I click on new, and then I type in Azure Databricks Delta Lake and then select that and put this. Now here, what I have given access token. How do you find the access token, right? I believe you can get it here and under settings. Yeah. So settings, developer, and access tokens. You cannot see it later, but you manage and generate new and put it there, right? I'm not doing that because I mean, I've already done. So you can take the access token from here and put it here, right? Put this access token here. But what is this domain and cluster ID? Go to this, my Databricks workspace. So here I will find this URL, ADB, right? Let's see if this URL is the same. ADB 130, that thing, Azure Databricks.net, right? So you see, this is this one. This URL you have to provide. This URL you have to provide here. And this cluster ID we can get from the cluster. So when you come here, you can see either somewhere under the properties, or you can just get it here, right? So if you see this 1107, right? So here is the cluster ID that you have. So go to compute, right? Click on your cluster and you can have it. There will be more ways to check that out, right? But again, that's one of the easiest way that you have your cluster ID. You mentioned that cluster ID here. So two things: domain and cluster ID, and that's it. That's it. Test connection. It should be successful, of course. Yeah, connection successful. Anyways, I will cancel that. So I've created a link service to connect to my SQL DB. I have created a link service to connect to my ADLS Gen 2. I have created a link service to connect to my Azure Databricks Delta Lake, right? So these three link services I have created. And key vault I am anyways not going to talk now, we will see later. So that's fine. Link services is done. So link services, all the three which were main, we have created, right? These are the three we have done, created. Now we would be creating data sets. data sets. From Azure SQL DB, we have to get the tables, right? So let's create the data sets now. So what I will do, I will click here, author tab. So if you want to create a data set, you click here and click on data set. Select what's your, let's say, are you looking to create it something for your ADLS Gen 2, or you are looking to create it for your SQL DB? Let's say I want to create for ADLS Gen 2, right? Gen 2, right? Now, in this, what kind of file I want to store, what kind of data set I want, right? Delimited text, or let's say a parquet or whatever. That way we have to create. That means first more like a link service name and then data set name when you are creating this. So let me first see the data set for Azure SQL DB, right? So you can see this, you can see what we are doing. So we have created this for Azure SQL DB, and we have selected our link service for Azure SQL DB. You can see this, right? We mentioned in dataset we have to mention what link service it is related to. So now we understood, we have given our credentials for Azure SQL DB, but in that, what table, what database, all of that, right? How do we know? So that thing. So link service we have selected, and then DB name. You remember last time when we created a link service, we have to give the DB name, but we still have not given. Here also, we are not providing the database name, right? So this is inherited. You see, link service properties. This particular thing is inherited from the link service, and it says you give the value, but we will still not give here. We will get it from the pipeline, which is the third level. So first is link service, then dataset, then pipeline. So let this value come from pipeline only, right? To make it dynamic. So basically, this is a dummy one. Actually, I should have clicked on the proper one which we did for Azure SQL DB, which was this one, generic SQL DS. Because again, our intention is to make generic. So let me delete this anyways. I'll delete it later. So this delimited text one and Azure SQL table one, these are of no use. So anyways, as part of part two, we will clean these two things. But this is the one that I want to showcase. So when we have created a link service for Azure SQL DB, we are creating data set for that, and that is generic SQL data set, right? Okay. Now in this we selected the link service, whatever we have for our Azure SQL DB. This is the one, and DB name we are saying okay. We are not passing. We are not passing this name, right? You see at the rate dataset dot DB name, right? So still we have not passed, right? So you can see there are three parameters. If you want to connect, what parameters you need, right? If you want to connect to Azure SQL database, right? So we know credentials are set, but we have to still tell the database name, which actually in link service we were supposed to tell, right? In link service only we were supposed to tell. Then we have schema name and database name. Sorry, table name, right? Because if we have to specify and get this, then we have to mention schema name and table name also. So we have two more parameters, schema name and table name. We have not defined the value, we are saying these are of string type. And when I go to connection here, right, you see DB name is something which is coming from link service itself. We have not created newly, it is coming from link service, right? I hope this is clear. And the table name and the this schema and table name that we have defined here as part of parameters, right? So we are not passing the value, we will get it from our pipeline itself, because all of these things will come from our configuration file which we have uploaded in ADLS Gen 2. That's why we were saying it's a metadata driven architecture. So all of these three things, these parameters, nothing we are passing, right? It's all we are keeping generic, right? We are saying at the rate dataset.db name, schema name, table name. We are not passing the value. We are not hard coding. We are saying we'll see it later. Later means from the pipeline itself, right? So this data set we have created, right? Then this is done. This is done. Azure SQL DB data set number one. So in terms of data sets, right? Azure SQL DB we have done, and we have not passed any of these parameters. This one we were getting from link service itself. This parameter we were getting from link service, but still we have not passed the value. And these two new parameters we have created, but we have not passed the value. We will see it from pipeline itself. Now, next data set that we have to create, right? Now uh, we want to basically read our configuration file also. Our configuration file is kept where? Right? Our config file to implement the metadata driven architecture, we have kept created a configuration file. Where we have kept that? That is in ADLS Gen 2. And that file is in what format? A flat file basically. Flat file, delimited file, comma separated, right? Delimited file. So we have to attach this link service, and we have to create a new data set delimited file so that we can read this configuration file. So I'll show generic ADLS flat file. That means any flat files we will be able to read. So using this generic SQL dataset, any SQL table we will be able to read because we have not hard coded what table name, what schema name. Same way, if any flat file we have to read from our ADLS Gen 2, we will use this dataset, generic ADLS flat file dataset, right? I hope this is clear. And what link service we have associated? Azure Data Lake Storage 1, right? That link service we have created, right? We have associated that. Okay. Now, in this, we have to tell from what file we have to take. Like, what we have to give is the uh, file path, file name, and apart from that, container name. In order to read this, we need all these things, right? So as part of link service, we know the credentials to connect to ADLS Gen 2. But now we have to give more details that, okay, what's the file format? File format is delimited file CSV, right? So we mention in this data set. What's the container name from which we read? What's the file path from which we read? What's the file name? All these things we define as part of the data set, right? So you see, we have associated the link service and this container. So we have defined container, file path, and file name as the parameters. All of this string type. And now we are just saying the file path. From what file, from where to read? Again, if you see, it should be landing, that's the container, slash. Inside that, we have created a folder EMR, that's the path. And then inside this, the name of this file was the name of the file. If I go and check quickly, it was uh, so configs EMR, not landing, sorry, configs EMR, and then load underscore config. So configs EMR load underscore config dot csv, right? So this is nothing but the container name. This is the file path, the folder name, and this is the file name, right? So we have defined. You can see this, that we have defined basically all these three parameters: container, file path, file name. And here we are saying dataset dot container, dataset dot file path dot file name. That's the total path from which it has to read. But these things I'm saying I will pass from my pipeline itself. I'm not hard coding here. I'm not hard coding because I'm naming it as generic. That means I should be able to use it for any kind of flat file then later, right? and no compression, comma separated file, all of those things, details related to the file. And first row is a header. So we have mentioned that, oh, it's a comma separated file, first row is a header, and uh, how to read the container, the folder name, and the file name, right? I hope this is clear. So we have created this also. So this will be able to read any flat file. This will be able to read any table, right? We have created generic way. Now, what other link service we need? Now, we take the data from Azure SQL DB through Data Factory and we load it to ADLS Gen 2 in Parquet format. So we also need in ADLS Gen 2, in ADLS Gen 2 link service, we need Parquet, Parquet file, right? So Parquet data set we have to create. So generic ADLS Parquet data set. Just like flat file dataset, same way Parquet. It also connect to same link service, which is our storage account, ADLS Gen 2. And here we have given the parameters again same way, container, file path, file name. Same way, just like we have given for our text delimited. But here the file type is Parquet. We have selected Parquet when creating this, right? So for example, if we have to create this data set, right? I will just show you uh, gen 2, and then I select Parquet here like that, and then I continue and do all of that. That's how we have done. The only difference is this file is Parquet here, and the compression type is snappy. And again, container, file path, file name, I'm saying okay, let it come from pipeline because it's a generic thing. I'm not hard coding these values here. So this is also set. So we have created a data set, generic data set for Azure SQL DB, a generic data set for delimited or flat file, a generic data set for Parquet file, right? Associated the link services also, right? So these are the three that we have created. These two are dummy ones. I will delete it later. Now, when writing to the audit table, right? Audit table, that means my, if I have to say Databricks Delta Lake, right? For that also I have to create a data set. So that's one that I have created. Azure Databricks Delta Lake data set, right? I created associated that link service, and if you see the parameters, when I am writing something to that or reading something from this, I need two things. One is schema name, and one is my table name. So I have these two parameters, schema name and table name, both of string type, not passing the values. And this database and table name will we will get from, so schema is nothing but like a database name. As I mentioned, schema name is nothing but database name. When you talk about your Databricks, schema and database is synonymous. Right? So this is again we will get from pipeline when we run the pipeline. So we have created four data sets that we want. So link services is done. On top of that, we have created data sets. Now we will create the pipeline. We will create the pipeline and have activities inside that. That's how it is. So now comes the part of pipeline. How to create pipeline otherwise, plus pipeline and pipeline create, right? So if you see, I come here, pipeline. Okay. Now I will show you this. What does that mean? So first of all, so pipeline is made up of activities, right? Pipeline is made of activities. Now, the first activity that we have is a lookup activity. You select from here. So if you just say lookup, you bring it here, right? So I got it, lookup activity. So basically what it do is it looks up for a file. So if I basically show you this, what we have done is I gave it a name, give some proper name. So what this will do, this will read the config file. So the lookup activity will read the config config file. Config file is wherein config folder, EMR config container, EMR folder, and we have that file. You remember this path. This path we want to read. So this is nothing but the container name. This is nothing but the file path. This is nothing but the file name. Right? I hope this is clear. So let's see. So if I go to settings, you can see here. I select the data set, right? In when creating data set, we put the link service. But now when creating pipeline, we put the data sets, right? So what data set? I mean, since I have to connect to my config file, that's my that's my flat file data set, right? Generic ADLS flat file data set. So generic ADLS flat file data set. Now, three things that I have to mention: the container name, the file path, and file name. Container name is configs. File path is EMR, that's the directory, and file name is this load configs. Right? We were avoiding to give these details, but now finally we have to give that. Right? So it reads this, and you can see file path in dataset. So it forms the complete file path. Recursively, it reads this file. Recursively, it reads this file. I hope this makes sense. You can just check this out. Right? Okay. I think you should not have any doubt. I mean, if you want, you can preview the data, but it will start a small cluster, right? So you can see this. I'm doing a data preview. The data preview session would have been on, right? Okay. I hope this should be pretty much clear to you. So when you preview the data, it will start a small this thing cluster in order to see that. So if you see, right, you can see your config file that you have. This was the same config file, right? That okay, which database, data source, table name, load type incremental or full, watermark column. So watermark column will be in case of load type incremental only, right? Is active. Right now I have not implemented that. Even if it shows 0, the pipeline will still be running for that, right, when I run. And target path, hospital A or B. Okay, so that's fine. I hope this is clear. Now, this file will be loaded like that. And now, after that, for each entry in this file, that means for each entry in this file, so we have how many? 10 entries, right? We have 10 entries. Now, we are using a for each activity, for each. So, if you want a for each, you just search for each, right? This one. So for each entry in this file, we want to do this, right? All of these things, right? So this for each will run in a loop 10 times that way. Let me click here now just to see what is there. For each entry, that means for the first line that it reads, the line that it reads, let's say, would be like this, right? Initially. For this line, it will do all of these steps. So first it checks that okay, file exists. So this is a get metadata activity. You can search this activity get metadata, right? So what this get metadata activity do it is it checks whether this file, let's say, it checks whether there is any file with the name, let's say, encounters, because first row was this encounters, right? So is there any file with the name encounters which is there in our bronze folder bronze folder, right? it will check that. So how it checks, you see, if it has to check something in the bronze folder, and of course now it is checking for parquet files, because if the pipeline has run earlier, it would create parquet files only, right? For this, you will understand that later. So what data set that we want to see here, it is generic ADLS Parquet DS, because we are now looking for Parquet files, right? Related to Parquet files now, right? So we have this Parquet data set here. Now container name bronze. So for example, if I uh, go to this and I go to bronze container, bronze. So you see inside inside this hospital A, inside this hospital A, is there any file with the name, let's say, what was that name? Encounters. Because first file was that, right? Encounters.parquet. This would be .parquet file, right? Anyways. So if you try reading the data, it will show in some random format. There is a lot of data, so yeah, anyways. So we want to see, is there any parquet file present inside a bronze container, right? Bronze container, and uh, hospital A or hospital B folder, right? So if you go to this particular thing, you see container bronze and file path. File path is nothing but when we ran. So if I go one step back here, when we ran this, right, it gave me it gave me this particular data, right? This particular data. Now in this, if you see that table name is nothing but this, data source is hospital A, and target path is host A, right? All of these entities we get as part of item. So let me go here and show again. Now it will be more clear. So you see, at item, that means whatever we got from the previous step, at item dot target path. Target path, you see this. What is target path? In this case, HOSE, right? So that means this will dynamically give you a value of HOSE for the first line, right? So file path will be, so I'll just write, container is what? Hard coded as bronze. You see this, container bronze. File path is what? File underscore path is nothing but whatever this at item. That means whatever previous tab has given this particular line. So I will just copy this here, right? So previous tab has given this particular line, first line, because it's iterating one by one. So target path is nothing but HOS A. That means hospital A, HOS A, right? And file name, file underscore name. We are saying item dot table name. Item dot table name is what? This one. So we get this, sorry, this one, right? And in this, what we are saying, split based on dot. So if we split based on dot, we get items of 0 and items of 1. So this encounters will be items of 1. So we are getting of 1, that means we get encounter. We are getting rid of DBA, right? So that means file underscore name is file underscore name is what? Encounters, right? That's how dynamically we get this from the first line. Now we are getting this. That means container bronze, file path this, and encounters. That means what it's checking that whether this a file with this name exists or not. And since we have selected Parquet DS, that means automatically it will check for Parquet file, right? So a file name slash bronze slash hospital A slash encounters dot parquet. That means when previously we would have run the pipeline, we would have got a file like this, right? Now, same case is there actually. So, if you see here inside container, we have run the pipeline earlier. So in bronze, Jose, we have all this because our pipeline was run earlier. So now when we run next time the pipeline, it sees that this is there. So we should move it to archive. That's what we are planning to do now, right? So it detected that, oh, this is there. So before we invoke it again, let's move it to archive. That's what we are doing, right? So exists. If it exists, right? If it exists, then what we do, right? If it's true, that means if the file exists, right? Then what we do is we basically, so I will write it here. If the file exists, that means if it is true, right? What activity we are running for that? You see this if condition. So activity is if condition, if exists, right? And if condition is true, then what we are doing? I'll just show you that. If it is true, then you think what we want to do? We want to move it to archive. From where? Source is this. So uh, source is this, and target would be what? Target would be the container is same. Let me just take it and modify. uh, Container would be bronze, right? Then in that archive, and inside this also we are creating a hierarchy of year, month, and day, right, before archiving. So archive, and in this year, month, day, and then finally we put the file. Finally we put the file, right? That's what we are doing. So let's see how we have done that. Source anyways is container bronze, target path which is host A, and file name which is encounter, right? You know that we are, this is our source. But sync, whatever target is nothing but, you can see again we want in Parquet, so same data set, Parquet data set. Now container is bronze, and you see the file path. We are saying item dot target path. What was target path? Host A, right? Host A, right? So you can see this. After that, we are saying archive. So before this, host A also, and archive, and then we are getting the current time using UTC now. So it gives me current timestamp, out of which I am extracting the year, right? Year. I'm extracting the month, and I'm extracting the day, right? So this is my path. So the path is nothing but the target path slash archive. That means target path, which is nothing but host A or host B, archive, year, month, and day. For, it gets the current timestamp and extract the year, month, and day, and that's my file path. And after that, the file name is nothing but whatever item dot table name, and separated by this. So same we will get encounters. So we are getting this. I hope this is pretty much clear to you, right? So you see, it's a similar path. It's a similar path. If I basically go here, containers, bronze, so host A, then archive, right? So before archive, this was there, right? The target path was there. So I hope this is clear. Okay. So this is fine. We have, so in case if the Parquet file was present already, then we are moving it to archive so that when we run it newly, it should not collide with that, right? That's what we are doing. So this is taken care. If it was true, we are doing this. If it was not present, then nothing. We do not have to do anything then. So only if file exists, we are doing this particular thing. That means when it is true, we are archiving the file. We are archiving it. And for archiving, I have shown you this code. Otherwise, no need to archive, because only if it is present, it is archived. Otherwise, no. And once it is archived, then we have to do the remaining activity. That means we have to get the data from. So the flow was the flow was first read the config file, right? Iterate over each entity one by one. In our case, 10 entries are there. So 10 entries were there. So it will iterate over each entry one by one, right? Using for each, right? And for each entry, it will try to run the pipeline. And we saw that the first entry was this, let's say. So it read this, and then what it saw, that if the parquet, if the uh, encounters dot parquet file is present in bronze folder, right, then we move it to archive before doing any other thing. And then after moving to archive, if it is present, move it to archive and follow the remaining steps. If it is not there in archive, if it is not present, then no need to archive, because uh, it's not there, and follow the remaining steps, right? What are the remaining steps now after archiving? Now what we want is, take the data from azure sql db and put in bronze uh, bronze container, right? Bronze container, that's what we want, right? So take the data from Azure SQL DB and put it to bronze container. Now that means when you have to take from Azure SQL DB, what data set you will use internally? So something we have created for Azure uh, SQL database, right? We have done. And when we have to put to bronze container, we have to put in Parquet format. So Parquet generic, right? So this will be for my source and this will be for my target, right? These data sets I will be using. I'll show you that. So you see, now next step is, you check basically if it is a full load or not. If it's a full load or incremental. How you will check? Because you get this entry, right? In this you have this load type, incremental or full. So you get items dot load type, and if items dot load type is incremental, we have a separate strategy. If items dot load type is full, we have a separate strategy. That's what we are doing. If condition, if condition, and you see this, what does it say? What's the expression we are giving? We are saying equals item dot load type full. That means if load type is full, that means if it is true, do this. If it is false, do this. The below one. So let's see in case of true what we are doing. That means if load type is full, right? If load type is full, what we need to do? I'll just show. If load type is full, what we need to do? We basically take all the data from Azure SQL DB, the entire table data. That means like select star kind of from table, right? And take it and put it to our Parquet file, right? Select star kind of thing. There is no logic of the watermark column and all. So let's see, very simple logic. So if you see here, I show you the source. Source will be what? Azure SQL DB, right? So that is SQL data set, right? Generic SQL data set. Now we have, when we have to source is uh, SQLDB. Connections and all were given in link service, but still we have to give three things: the database name, right? We have not given that. The schema name and the table name, right? We have to give these three things. We have not passed it earlier. Now, how do we get the database name? The database name. So we get it from here. We get it from here, the database, right? That okay, it has to read from Trenditech Hospital A. So that is items dot database, isn't it? How do we get now schema name? Schema name. Schema name will be schema name will be we take this table name and kind of split it based on dot and then of zero, right? This particular part we extract this first part from this table name. And how do we get table name here? We extract the second part from this table name. So items dot database will give the database name. Items dot table name split of zero will give this schema. Items dot table name split of what one will give us this table. So we get all of this: items dot database, items dot table dot zero and one. So this is how we are getting these things. So we are not putting it. We are getting this line from configuration file and it's automatically taking from here based on the configurations, metadata driven architecture, right? Okay. And it connects to this table. What it has to get from the table? What it has to get from the table? It has to just say select star, right? It has to say select star. Uh, Apart from that, we get all the columns from the table, whatever. Apart from that, I want one more thing: data source. Item dot data source. Item means whatever this config file is given dot data source. It will give me host A or host B. So just for my reference, in my Parquet file, I want to have one more column that okay, what's the source? Is it hospital A or B? So that is again added hospital A or hospital B as data source from what item dot table name, right? From item dot table name. I hope this is clear. So we have given a query and this will get all the data from counters table. It will, let's say if it has 10 columns, it will bring all 10 columns, plus it will have one more column which is nothing but the data source like host A or host B. That means we understand that whether it's coming from hospital A or hospital B. So I hope this is clear. So now once the data is copied, what you want to do? We mentioned, right, we are maintaining a audit table so that we can keep a entry for, I mean, once this is done, we want to add an entry in the audit table. So now audit table is nothing but your stored in your Delta Lake, right? So if I go to settings, you see Azure Databricks Delta Lake dataset, right? And this schema and table you can provide randomly because you are providing a query. See, if there are two ways, either you provide the schema name, table name, and you can select table here, or when you are giving query, this does not come into picture. So what we are doing, right? I take this and just talk about it, right? So we are inserting into audit. Audit was the schema. This was the table name. We are storing the data source, the table name, number of rows copied. All of these columns we are storing. Now we have to put the values. What values? So data source is what? Item dot data source. We got it from the config file itself, right? This one, this whatever we were getting was item. So item dot data source. So many things we will get from that. So item dot data source, item dot table name we are getting from this again config, and whatever previous activity ran, right, in terms of copying the data, that full load activity will also tell that how many output rows copied. So activity name dot output dot rows copied will give us how many rows copied. Items dot watermark will, from that config, it will give me the watermark table column, I mean, right? And UTC now. Anyways, watermark column and all does not uh, come into picture because it's a full load. And UTC now is current time. That means at what time this pipeline has finished for this particular table. So that's how I am putting each, after this finishes, I am putting an entry, right? I hope this is clear. Let me see if my Databricks cluster is turned off. Yeah, that's fine. So I hope this is clear to you. So you understood about the full load, right? You understood about the full load. So how the pipeline was for full load was, we saw the config file for each entry. Let's say we are talking about the first entry now, right? If the file is already Parquet file is already present, we archive that. After archiving, we see whether it's a full load or incremental. If it is a full load, we come here, right? And we kind of take all the columns apart from that one extra column, and we create a Parquet file. Once that is done, then we put an entry in the audit table, which is in Delta table, right? Now, in other case, when this is not a full load, right? When full load is, when this particular thing is not correct, equals item dot load type full. When this is false, then it will come in this part, this false part, and that will be our incremental pipeline where watermark column will be handy. So what does it say? So whenever we have to handle an incremental load, first we have to check the delta table. That okay, what's the last time when the pipeline ran, and we have to take the data only after that time. So we have to have a lookup activity. Whenever we want to read something from a file or a table, we have to have a lookup activity for that, right? So we have a lookup activity, and if I go to settings, I am mentioning the data set so that I can read something from my delta lake data set, right? This, anyways, I am giving dummy, right? Not required, because when I am giving a query, then this, all of this is overwritten. And now I am just showing what pipeline I am mentioning for incremental, right? For incremental, first I am going and checking the audit table. First step is check the audit table, and this is how we are checking, right? What we are doing, so from audit table, what do we want? The load time. That means when this, or till what time the data is loaded. So what we are saying, select, right? We are saying max load time. Max load time in the audit table, in the audit. So I just will show you the audit one, uh, audit table. Anyways, I have not run it till now. So in the audit, so it will be load time, right? That what time it was loaded earlier. So current timestamp we were mentioning. So only we have to get that and only load data after that time onwards, right? Isn't it? Because that time the pipeline has run. So what we are doing is, what we are doing is, we are checking the max load time from that, right? Max load time. And if we are running it for the very first time, it won't be there. So that's why we are saying coalesce, like, so that if it is null, then please give me a very back date, some very old date. If we are running the pipeline for the very first time, then we will get this. And if we are running it for the second time and all, then we will get the max load time, right? As last fetch date, that means we have fetched the data till this point, right? And this max load date will give us some timestamp. Timestamp means date along with some time, but we are casting it to a date. So if we are getting, let's say, yesterday's date along with some time, then it is truncating to date only. It is removing the time part of it, right? Now, where data source right? Data source is item dot data source. We get it from the config file, right? Item means we get it from the config file, and table name equal to item dot table name. So this will be item dot data source. If you see what it will be, uh, host A, and table name will be dbo dot encounters, right? So I hope you understand that you can get the data from this particular audit table. You can get the data from this particular audit table, because you remember we have created a schema also. The schema was either this, right, host A or host B, right, which is nothing but data source, right? So we are appending the schema and the table name, right? I hope this is clear. So from this audit table, right, we are getting the record. So if you see this audit table, I do not have the audit table, but these will be the records. So I basically see for that table that data, because a table might be from two data sources, hospital A or hospital B. So I need to check what hospital I am referring to, and accordingly see that particular row, and I have to see the last load time, right? So now once I get the last load time, right, let's say it is some date, let's say today is what, 23rd November, let's say it is 21st November 2024, and sometime 8:54. I mean, do not check the format and all. So let's say this was the last time. So after getting truncating, right, after casting to date, we will just get this part, right? We will just get this part. So we understood that we have handled the data till this part, but now when we handle newly, we handle this date and beyond, right? We will still handle this date again, so that if there is any overlap for this date, that it will be taken care. Let's say uh, we handle for this date again, that means all the records which were processed till 8 p.m. will also reprocess. That's fine. On a safer side, we will still consider equal to or greater than this date, right, next time. So that means all the records which I have processed till 8:54 p.m. earlier will also be reprocessed next time. That's fine, because I want to have a safer approach. Generally, dealing with EMR, the systems are not that great and might have this kind of issues. So I want to be very, very safe and make sure, okay, I am ready to reprocess, because anyways, my pipeline will be a idempotent pipeline. It's not that if I reprocess or reload, it will create issues or create duplicate records. It won't, right? It will merge it. My pipeline will still have the same results no matter how many times I run it, right? So I still consider for this date and any other date beyond that. So let me go here, right? So from the lookup table, I understood that when last I read that, right? And after that, I can now implement my copy data activity. In my copy data activity, I will use this particular date, whatever I have fetched. So in copy data activity, what data sets I will use? I will use something for SQL dataset, SQL generic, and I will use Parquet. So source will be SQL dataset, because I have to read the data from SQL, right, DB. And now again, the database name, the schema name, the table name that I have shown for full load also, same way we are getting. No change, right? No change. And the sync, that means the target is the Parquet data set, right? So we have to load it to bronze container. So we have to load to bronze, and inside this, where we have to load, uh, we have to load to the target path will be either your hospital A or hospital B folder, right? uh, Target path, that's a folder, right? So if I have to say this target path, and inside this the file name, file name anyways will be, if you just take this table name, you get this, split this and get the second part, encounters. We have seen that earlier also, right? So you kind of understood that we load it here. And after loading, right, after loading the data, you can see this query first of all to load. You can see this query to load. I am selecting select star and additional one more column for my reference as data source, from item dot table name where, right. So from this table where item dot watermark greater than or equal to this particular date, right? And this date was, I mean, how do I get this? I have fetch logs activity, right? Just now I have the previous activity. This is fetch logs, right? From fetch logs activity, the output and the whatever first row I am getting, right? From fetch log activity, the output first row whatever I am getting, and in that this column, last fetch date, right? Last fetch date. So this is nothing but this particular last fetch date, and this is how you have to give activity fetch logs dot output dot first row, because only one row, right? And last fetch date, this column name. So row name, column name, right? And that's how you are saying that get me only records after this particular date, and this date will be, let's say, replaced with this after or equal to. So whatever you have processed might come again, but since later, I mean, you would implement your slowly changing dimension and all, it will merge properly. You do not have to worry. I hope this is clear, right? So this is our incremental, and watermark columns help us here. And once all of this is done, of course, then you have to again go back to your delta table, right? And store this last, I mean, current timestamp, so that you say till now I have, I mean, sorted all the data taken care till current timestamp. So after that, to write again to a table, you have a lookup activity, right? Lookup activity, and again the data set will be your delta, right? Delta lake data set. And this anyways dummy not required, because when we are writing a query, right, this is all fine. And now I take here and show you this. So finally we update this, or add one entry to this audit table. Insert into audit dot load logs, right? So we are inserting now, right? And we have this column names, what values, item dot data source, that means the config details from the config file whatever we are getting, and activity incremental load cp dot output dot rows copied, that how many rows were copied. So I mean, once we get to know about this activity, we can get output dot rows copied, right? And what was the watermark column, and the UTC now. That means the current timestamp we are mentioning. That means all the data sorted till current timestamp. That means all the data we have taken care, loaded till the current timestamp, right? And that's how we add a entry to the audit table. I hope this is clear. So now let me go back, and with this you can see we have taken care about it. So how this pipeline flows? First you read the config file. So whenever you have to read a file or a table, lookup activity, right? Lookup, and then anything if you want a true or false, then if condition, right? And if you want a loop kind, then for each, right? So all of these things. So if you see, lookup activity to read from the config file stored in AD less than 2. Then for each entry, you have this for each. And then for each entry, what we are doing, again, get metadata to understand what elements are there, right? Uh, if the file was present, then we archived it. And after archiving, we see whether it's a full load type or incremental using the config details. And if it is full load, we kind of take all the data, put it, dump it in a Parquet file, and update the audit table. If it is incremental, then we first fetch the that what was till what time we have loaded the last time we loaded, right? We get that, and then we take all the data after on and after that date, right? And then we then again finally update the this thing audit table again. That's how we have designed this pipeline. Now, in order for me to run this, uh, right now you see audit table is clean. Now I can definitely run this thing. So to run this, what I will do, uh, I will uh, I will basically go to the pipeline, and I will say add trigger now, and I will run. Okay. Now this will start. I can go to the monitor tab and start monitoring this, right? So this you can see will start. Now one challenge that is there with our current pipeline is there are 10 entries, right? That means 10 data sets will be loaded from the tables, or 10 tables will be loaded one by one. So there are two options. It could have been done sequential or parallel. For parallel, anyways, we need more resource, but that's a different activity. But right now, our pipeline is sequential. Now you might say, why, sir? Why sequential? The thing is that the thing is that when you see our audit table, it has this ID which is a auto increment column, right? So in parallel, we cannot update this. In parallel, this cannot happen. Only in sequential, this can happen. And in my part two, we will solve this problem and we will make it parallel, right? Because it should not be sequential, because one table is not dependent on another. So it should not be sequential. So this is one of the limitation, that this is sequential right now, because with this auto increment, if you try to update this auto increment in parallel, it will fail, right? So that's why the pipeline is sequential. And how do you make it sequential? When you go to the pipeline, when you go to the pipeline, I'll show. So you can see under to settings, we have checked this sequential. If you do not check this sequential, it will be parallel, but it will fail because of auto increment, that each thread will try to update that, right? That will not happen. So we will solve it in our next part, but for now the pipeline is sequential. If I go to monitor tab, the pipeline will be running, right? The pipeline will be running, you can see, right? So anyways, when it runs, I'm not sure if our cluster is on. Um, the pipeline might fail also because our cluster, Databricks cluster, might not be on. Let me quickly turn that on, the cluster on. Compute. Okay, it's automatically trying to turn that on because we are trying to see that, right? So it will try to turn the cluster on in this case. And once the cluster is turned on, then it will be able to write and read from this delta table, right, which is the audit table. So that's why all of this is waiting for now, because this fetch logs is not will not happen, right, until the cluster is turned on and we are able to see that table. So it is trying to turn on the cluster, whatever we had. So let's wait for it. By the way, if you have been watching this video and enjoying this, please make. So initially, when we are running this, the audit table is empty, right? So any full load anyways will take care, it will happen normally, but the incremental, it will take 1990 as the last time when it ran, right? Because we use coalesce function. So let's see if cluster is created. Things will happen now. Things will happen now. You can see things are in progress, and things will happen soon. Now, if cluster is created, then I will go to workspace. I will go to audit table, and I will just say select star. Earlier we saw nothing was there. Now also nothing might be there, but it would be working towards that. Once any of the table is finished ingesting, it will have the entry here mentioned. So you can see fetch logs has worked because the I mean cluster is created and it would be able to read the delta table, right? So right now incremental load is happening because the first table itself was incremental load. You remember, right? That was the encounter table. That was the incremental approach we have to follow. So it is, you can see incremental load CP activities going on, and it has around 10,000 record, and we have very minimal resources, so that's why it's taking time. So this pipeline will take some time to run because it is sequential first of all, right? We will make it parallel later. So anyways, let's see. I think probably because of query timeout, let me see. It will try to again run that. It will try to rerun that basically. So let's see if anything has come. Now I can see one incremental load. Refresh this, then definitely I should see something because it would write to this, right? Or it's yet to be written. So incremental load. Now insert log. So you see, first it fetch the logs. So how is the flow? So it checked the if condition whether it's a full load or incremental. It saw it was a incremental, so it fetched the logs. It understood when it was last fetched, and after that, what it did, it did the incremental load based on that time. It inserted once the incremental load is done, is it inserted one entry into the audit table, right? Now you can see definitely one entry would be there in the audit table, and you can see this hospital A, DBO dot patients, right? Number of rows copied 5,000, modified date, load date, all of that, right? So this it has done, and I think for some reason when we were first row was encounter, and I think we do not have, we have not set retries, but due to the server took lot of time or the cluster took lot of time to start, so it would have failed because of that, right? So we can check out why it failed, right? But you can see this is working, but now things will happen one by one, and it will take some time, right? Now, if anything else fails, then definitely we would have to look whether it's able to not connect to a database or something. But only that time things have failed when the cluster was not started, right? If anything fails now, we will have a look. Ideally, the cluster should have been running. The cluster was off and we started the pipeline. So let but now we have covered a lot, right? And I am sure you would have learnt a lot from this. Now if you basically see that in our part 2, what I want to show in our part 2, uh, which will be coming soon, and once it comes, it will be mentioned, right? uh, we will implement the silver layer. In silver layer, what you will do, you will take the data from bronze, and you will take the data from bronze, you will clean it based on certain data quality checks. You will implement a common data model. You will implement a slowly changing dimension type 2. and then data will be stored in delta tables, right? Not no longer just plain Parquet files, delta tables, right? And then apart from that, we will be implementing a gold layer, implementing gold layer, right? And gold layer where we will be creating facts and dimensions, facts and dims, basically, right? Now we will be also implementing a key vault, implementing key vault, right? As to store our credentials and all as part of best practices. We will improvise on our naming convention, improve the naming convention as per industry uh, conventions, right? We will make our ADF pipeline parallel. Apart from that, we will also see that how to get the data from APIs, right? Whatever we said that we get doctor details and the codes, right? We will see how to get the data from APIs. And apart from that, what we will do, we will understand more about the claims data, because till now we have not dealt anything with the claims data, right? Which insurance provider have put as uh, uh, flat files, right? Now, you remember we have a is active flag 0 or 1. We have not implemented it till now. We have to implement that. Is active flag implementation, right? And then we have to implement. We can implement the Unity catalog. Right now, our catalog is a Hive Metastore. So right now, our catalog is a Hive Metastore, which is local, local to a Databricks workspace. Not recommended because other workspaces cannot see what tables and all you have in that, right? So that's where it's always good to have a Unity catalog, centralized metadata repository, so that it acts as a centralized thing, and other workspaces can also interact with it, right? So let's see what's happening. I hope more tables would have done by this time. Okay, four tables are done, and you can see two of them were incremental, two of them were full load. So provider and department full load, patient and transaction incremental. That's why we have watermark column, which is modified date, and you are getting that load time. You can see that. So total 10 tables, it will take another 5, 7 more minutes. You can understand that, but you kind of got a gist. So these are the things that I will be mentioning as part of part two. If you feel that it's good to mention some more things, do mention in the comments, right? That what more things you want me to implement as part of part two, because I want this to be a very, very good project. Until now, you would have understood about the quality of this, right? You will generally not get it as part of even paid contents, this kind of project. And this is not a dummy scenario, this is a real world project. Of course, data set we have mimicked, but this is a real world project, and if someone is from healthcare, you would very much relate to this, right? And I was talking about our Hive Metastore, right? So if I go to this catalog, you can see we have this audit schema, that is a database like, and load logs, this is our table name, right? This is our table name, and we have these columns. So this is a Hive Metastore which you cannot see when you are in some other Databricks workspace. So better thing would have been that if we would have done it or created this audit table as part of our Unity catalog, so that it can be discoverable outside also, right? That's as part of good practice we should have done, which we will certainly implement later. So whatever parts we have missed or where we have not followed best practices, we will try to implement in our part two. So let me see what all is done till now. Uh, so if I go to my workspace and audit table, let's see how much is done, right? Totally, six tables are done. Four more are yet to be done, and it will be done. But you understood kind of what is happening, right? So the data would have been moved to archive also. So I guess it takes generally, not the, I mean, current IST. Some, why, as per those time zone, it will be 22nd November. That's fine. But you see, this is coming in the this particular table. So basically, the data will be taken from Azure SQL database and A or host B, right? Hospital A or B, right? All of this. So you see this file, 23rd. Now you can see it's 4:42 a.m. actually, right? It's almost morning now. I wanted to release it, so yeah. So you can see this time. You can see, right? So these files have just come now, some time back only. So you can see department, patient, provider, and transaction have come now. This encounter was little later because it failed because the cluster was not up, right? So, anyways, and same way for hospital B also, it would be there. You can see encounter, patient, provider, transaction. So almost done, right? Almost done. We can see total 8 or 9 tables would be done. Eight done, right? So with this, we have implemented a very beautiful solution to bring it to our bronze, the EMR data to our bronze, right? Uh, Now with this, I would end this. But before all of that, what I would need is that you make sure you clean your resources. In terms, what I mean to say is that, go to your compute, stop that, right? Go to your compute, stop that. Apart from that, ADLS account is fine, it won't charge much, very minimal. Your data factory, even if you have created but not running, then it's fine. So nothing, compute resources is something which you have to turn off, right? So make sure you do that, and then things should be all fine. So with this, we are done, and I hope you would have truly enjoyed the session. Do mention in comments about how you liked it, and subscribe to the channel. And I will come up with the part two very soon with all of these things, plus some extra things which you would mention in the comments, because I want this to be the topmost project on YouTube for Azure data engineering. So with this, we are done. Hope you liked it. Thanks a lot. So let's get started with the part two of the Azure Data Engineering project. Part two, Azure Data Engineering project. By the way, I'm pretty sure you would be aware that my name is Sumit Mittal, and I offer a ultimate data engineering program. You can check out the link in the description, and it's a program which has changed several lives. So without any further delay, let's get started with part two. Now I have a very clear assumption here that you are only seeing this part when you have seen part 1. So if not seen part 1, then please see that. Please have a look at that. And I will provide that under the description again, link to the part 1, because it's very much related to that. It's a continuation of that. Okay. So now let me show you the architecture diagram that we were talking about. I'll show you the architecture diagram, and this was the one that we referred. So, do you remember what data sets we talk about? So, we have EMR data coming from two different hospitals, let's say. So, one second, I'll move this here. Uh, okay, so we have EMR data we mentioned about, right? Electronic medical records. and this is coming from two databases. The data sets were, if I can recall, the patients data, right? Patients, we have providers nothing but doctors. So patient is, let's say, someone visiting to the hospital. Provider is the doctor itself. Then we have department, and then we have transactions. We have talked about all of those, and encounters, right? In case if you cannot relate to this, please check the part 1. So we are getting this from two different hospitals, let's say. So if you see this, we have five data sets coming from uh, SQLDB here, and five data sets coming from this, both of this, hospital A and hospital B. Now, then we have some claims data which insurance company upload in the landing folder. So we have claims data, right? And it will be put in the landing folder. By the way, this EMR data was there. Where exactly it was? It was in Azure SQL DB, and we have already created a data factory pipeline to bring this data from Azure SQL DB to our bronze layer in Parquet format. So we already got the EMR data from both the databases, right? In uh, in bronze layer in Parquet format, and we wrote the we created a ADF pipeline for that. You remember the pipeline was very generic. It was a metadata driven pipeline so that we get the parameters from a config file and so on. So these five data sets are already sitting in bronze layer. So in this case, the landing layer is skipped because landing layer is when some third party dumps the data in the landing layer or the landing zone, right? So now we have this payer files. Payer is nothing but the insurance provider mainly, right? So the insurance provider uh, dumps dumps the claims data in landing folder landing folder or landing zone, right? So you can see this insurance company, a third party, right, would be putting a CSV flat file. So in landing zone, whatever is there will be flat files. In bronze layer, whatever is there is Parquet files. In silver layer, we will have delta tables. Gold layer also delta tables, right? So again, if I have to say landing, we are having flat files, that is like CSV. In our case, it's not always that in your case also you would have it the same way, but in our case, that's the thing. We have to be consistent. Bronze, Parquet, silver, delta tables, and gold, again delta tables, right? So in some cases, landing zone will be skipped. What are those cases? When we are directly, let's say, pulling from a database. But if some third party has to put, they will put it in landing zone itself. As you see, pair files which will come here, right? And also, when we are calling the APIs, let's say we have some public APIs, when we call, we can directly bring it to bronze layer then, right? If we are ourselves calling the API, we can skip the landing zone. So if you see, if you see EMR data, whatever data sets is in what? Azure SQL DB, right? Azure SQL DB, and then we have uh, claims data, claims data which is a flat file in landing zone, and then we have this NPI for the doctors and the ICD codes. I have talked about these two codes also, which we will call public API, and we will directly get it to bronze. So this we directly get bronze, and this also we will directly bring it to bronze. No role of landing zone here. You can see this, these two, no role of landing zone. This also no role of landing zone. Only this pair files are put in landing zone and we take it forward. Now there is one more type of code which is called a CPT code. CPT code, I'll talk more about it, right? This also we could have called a API, but let's assume this is provided by a third party vendor and it comes as flat file, like a CSV, and again it is given in landing zone, landing zone, right? So our architecture diagram do not show that, but assume that there is something called as CPT code, right? CPT code here, which again is dumped in landing zone here like a CSV file, and then we take it forward. So it's more like the claims data. The flow will be like claims data. So this is about data set. So now what we will be doing, our intention will be first we will set our bronze layer. That means we have to make sure our bronze layer is complete, right? Right now, in our bronze layer, we have got this data, which we have done in the part one itself, where the pipeline we have created was a very good pipeline we created, a generic pipeline. Now we have to bring claims data, right, from landing to bronze. Then we have to bring this uh, ICD and NPI codes from the API call to bronze directly. And then we have this CPT code which we have to bring from landing to bronze, right? So if I have to write claims data, which a insurance provider has put in landing, right? So we have to bring from landing to bronze, okay? Then NPI and ICD data, right? This we call API and directly get it to bronze. Call API and directly put to bronze. Of course, when I am saying bronze, I'll put it in Parquet format. All of these things. And again, CPT data, we again bring it from landing to bronze. So CPT data usually follows the same thing just like claims. The flow will be the same. So again, I'm saying in bronze, note that in bronze, everything we are keeping in Parquet format, which is quite optimized, right? Parquet format. It is a column based file format, and when you use column based file format, we get really good compression also, right? And that's the best format to be used along with Apache Spark. Just to let you know. Now, in case if you want to know what is the difference between CPT code and ICD codes, I have a link here. I have a link here. So let's see what does it say. You can go through that, but at a high level, if I have to say, ICD code is a 10-digit code. You can see this 10-digit code, and it stands for International Classification of Disease, right? So, in other words, they refer to specific condition that's being treated. Let's say someone has attention deficit disorder (ADHD), right? So, it's the kind of basically condition that someone is treating, right? On the other hand, when you talk about CPT codes, it's more like the the procedure that's the medical is giving, right? They explain what healthcare provider did during an interaction. So it's more like a procedure, right? So you can read more about it. I do not want to go too much in that domain, but I just want to highlight that this link you can go through to check difference between ICD and CPT codes, right? I hope this should be clear. There is some difference between these two. You can go through them, and then you will also get to know from this link how frequently these are updated and so on. So we are good now. Now we will set our bronze layer. Bronze layer will be set when we do this thing. And before that, we have already brought in the EMR data from both the databases, right? But this is yet to be brought, so that we say, oh, bronze layer is set and this can act as our source of truth, right? Anyways, when we feel there is some problem in the silver layer or gold layer, we can always go back to the bronze layer and assume that it's our source of truth. Now, again, as I say, this is like a medallion architecture where we have bronze layer, silver, gold, and each layer serve different personas. Bronze layer is more for data engineers, right? Silver layer, clean data is more for data scientists, machine learning people, and gold layer is more for business people, where who run reports and all, right? So each layer can serve different personas. Now, once the bronze layer is set, then what we will do? What will be our task in this project? We will try to set our silver layer, right? That means we will get the data from bronze to silver. That, so I am giving you a high level idea first, that what we will be doing, what is left, right? So our activities to set the bronze layer will be this, and then once bronze layer is set, we will have to get the data from bronze to silver. And when doing that, we would have to clean the data. That means if there are nulls, we have to mark that, oh, this is bad data, right? If any of the fields are null, let's say, we clean the data. We implement common data model. We will implement common data model. What is that? Let's say we have two different hospitals, and each hospital has a different patient table. Let's say some column name is different, or the schema is different. Then you have to bring it under a common schema, and I will show that practically to you, do not worry. We will implement common data model. We will implement SCD2, so that if some record gets changed, we do not lose on the history. We maintain the history using slowly changing dimension, which is an industry practice. Even I will show how to implement SCD type 2, right? And finally, in this silver layer, we want to keep the data in delta tables. Now, underneath delta tables is Parquet, right, with some locks on top of it, so that we can perform transactions, updates, and all, right? So this is even a better version of Parquet you can think of. So internally, the format is delta when we talk about delta table, and delta is nothing but a refined version of Parquet, right? Parquet plus something on top of that is delta, right? And what is that something? Something is that extra logs which helps us to make updates. We can be acid compliant and all of that, right? Okay. Now, once our silver layer is set, then we uh, bring the data from bronze to sorry, silver to gold. We set our gold layer, right? We'll implement the gold layer, where we will create facts and dimensions, facts and dims. Now, if you are again confused, I have shown you that how exactly that will look like. We will have a fact transaction and some dimensions, and together these can be joined to create various reports. It can serve various queries, and various uh, KPIs can be calculated using this, right? That, okay, I want to understand for how long the, like, how many claims are not processed within 3 months, right? Or many such KPIs you have seen that earlier in part 1, right? So basically, in this, if you see, this part was done, this part is left, this part, and apart from that, CPT codes, right? This part is left, and then we take all of this forward to silver and gold, right? So that's what we have to do. I'll just close this diagram for time being. Okay. Now, after this, silver to gold, that's fine. Setting up bronze, then setting up silver, then setting up gold. And then, as I mentioned, we have to follow certain best practices, right? Certain best practices, or I would say enhancements to what we have done as part of our part 1. So we did something in part 1, it might not be done the best way. So we would have to correct that, and I highlighted those points towards the end of part 1, right? So right now we were just openly keeping our credentials. We do not have to do that. Rather, we have to implement key vault, so that I mean, our credentials are secured. It's not open to everyone, right? I will show how to implement keyword. We have to improvise on naming convention, right? Okay, we have to make our ADF pipeline parallel. You remember that last time when we were bringing those 10 tables, 5 from one database, 5 from another, it was all sequential. And the reason being, in audit table, we have the auto increment key. And if we have the auto increment key, people cannot update that in parallel, right? That's where we have to keep it sequential, and the pipeline was taking a lot of time to run. Now we realize that this auto increment key is not required. Why to have that? So we remove that, and we can now make it parallel with that, right? So that pipeline can run in parallel, and it can complete very, very fast. Now, we have not implemented the is active flag, even though we were getting that in our configuration file. Is active, right? Is active flag. So we will implement that. That means if is active is 0, that should not run. If is active is 1, then that pipeline should run. That we will implement. And last time we were using Hive Metastore for storing our metadata. But the thing is that it's not recommended to use the Hive metastore. It's kind of deprecated, right? So it's something which will go away soon, I believe. So if you really want it to be shared across multiple workspaces and everyone can see that, then it's always better to use Unity catalog for your metastore. So implement the Unity catalog that we will be doing. And of course, as part of best practices, we should be adding retries in our Azure Data Factory pipeline. That means if due to some network issue or whatever, if it fails, it should try again. So we will add retries also, right? And that's it, I believe, at a high level, if I have to think of. Now, before we continue and start implementing these things, right? That means in bronze, this all is left. Then from bronze to silver, we have to take the things. Silver to gold, we have to take the things, and we have to implement all of this. Before proceeding now, few things to note, right? Few things to note. I remember in my part one, some people mentioned that there is some data discrepancy and all that can happen, right? Even I have tried to correct it to some extent, but still data discrepancies can happen because all the data provided to you is generated using Faker module, right? Using Faker module, it has been developed. So I show you if I show you my Azure data bricks, right? One second. Azure data bricks, and I launch the workspace. I'll give you this notebook also, the where I generated the data sets, and you can see data generator faker module, right? This notebook is there. So here the code on how to do that is there. I can even pass on the code. You can just try it out, right? But I do not want to go into it. So all the data is generated using faker module, and there can be some discrepancies. I have tried to minimize that, but still you can assume some discrepancies will be there. Okay, so that's number one thing because some people were mentioning about data issues. Now, anyways, you have to understand the logic and the complete flow. Even if data is discrepancy, that's fine, right? Uh, so some of the due to this Faker module, data discrepancy can be there, and some joins and all might not work. Data discrepancy and joins might and all some join conditions might not work, but that's totally fine. So just wanted to highlight you this part. Okay, uh, fine then. So with this we are good, and now we are in a position to proceed implementing all what we have to do now. So we have even improved our naming conventions. Just to let you know, improved the naming convention. And I mean, even if you see, we have created a different folder structure to organize the code well, right? Organize the code well. I'll just show you that, right? So if I go back to my data bricks, right? I created a new. It's the same workspace or new one. I'm not sure. TTHCABDWS. That means Trendy Tech Healthcare Azure Databricks Workspace. Right. So the name itself indicates what this resource is. Right. So the workspace name is given accordingly, and inside this, so you see this, right? This because it is kind of synced with GitHub, right? So we created a new feature branch and just checked in there. So anyways, I will even talk about it a high level how to do that. But if you see, now the code is organized well, right? Trendy Tech Azure project setup, right? This is setup code, API extract. So this is where we are calling the APIs. Silver, that means from bronze to silver, whatever code is there, here we are doing. Gold, that means silver to gold, whatever code here, right? All of that. So you see the code is organized better, and we have changed our naming convention to make it definitely better than a previous thing, right? So we are good now. Now I will just show you the setup part. In setup, we have brought the audit DDL, right? You remember we were creating that audit table, if you can recall. So that we have brought to the setup folder, and ADLS mount. Mounting and audit table, these are part of setup you can think of. So if I show you this audit DDL, create schema if not exists, TTHCADBWS. That means this particular kind of database we have created under our Unity catalog. I'll just show you that. So if I go to catalog, open a new tab, right? So you can see TTHCADBWS, right? Here we have audit. Here we have audit. So basically, if you see, this is nothing but, so you see, this is nothing but the catalog name. This is the database name, and this is nothing but the table name. So catalog, database, table, and this catalog is a Unity. It's inside the Unity catalog, not our Hive Metastore, right? So this again change that I have done. You can check it out. So create schema if not exists. This, that means if this particular schema is not there. So how it is called is, in Unity catalog we have catalog name, right? Inside a catalog name we have schema name. Again, schema name is nothing but database name. Think schema and database are same. And then we have table name. So what we did is, in our Unity catalog, we can say click, right, add a catalog. We can create a new catalog, right? Create a new catalog using, so go to catalog plus add a catalog, and this way you will be able to create a new catalog, right? Once you created a catalog, what you need to do, create schema if not exists. Inside this catalog we are trying to create this audit. Either you say this is schema or database, whatever. That means you are creating a audit database if it is not existing inside this catalog. Now I just show you. So audit is there now created. So if I run this again, it will not throw me an error, because if it exists it will skip that. So now, if it is not, audit is not there, it will create. Now, let's say audit is created, then create table if not exist. That means if table is there, then do not show me an error. But if table is not there, then please create it. So create table if not exist. Inside this catalog, inside this database, I am creating load logs. So if you see, it will be load logs. This is a table. You see the column names, right? And I am giving data source, table name, number of rows copied, watermark column name, and load date. Now, watermark column name helps for our incremental load. Load date also, because till what time it was loaded, again, things are taken care from that time onwards. Number of rows copied, we are putting table name and data source. You see, we have removed that auto increment thing, right? The first auto increment, this field is removed because that was kind of not helping us with our parallel thing, right? That was stopping us from doing parallel activities. So we have removed that, right? And then in case if we want to truncate that, this is the command and select whatever. So right now, let me see if I mean, anyways, the cluster is not running, so I am not running this as of now. That's fine. So you understood about this audit DDL. Now, audit DDL slight change was there. It's just that we removed the auto increment. Now ADLS mount. Now, in the previous mount, what we were doing, we were mounting the landing zone, right? But now, let's say we want to create a mount for our landing, bronze, silver. So we created an array. We created, instead of just one mount, we want to have multiple mount points like slash MNT slash landing, slash MNT slash bronze, slash MNT slash silver, like that. I hope this is clear. One second. Okay. So now, if you see here, if you see everything is same, and we are iterating over a for loop, so that one by one it creates the mount point. Now, one interesting thing that you have to see, we are not giving the storage credentials here. Earlier, we were hard coding the credentials. Storage account access key we was giving directly here. But now we are not hard coding. We want to do it through key vault, and we have created a key vault, and we are using this here. I'll just write it. I'll just write it to my notepad. So we first created a key vault. I will show how to create, and then we are using. That means from this scope, right? From this scope of key vault, we want to get the password or the authentication token for this ADLS access key, right? That means Azure Data Lake Storage, whatever is the account access key, right? Please give me that, and it is stored in Key Vault. It will retrieve from that, right? So this is the scope. From this scope, I want to get the value for this key, right? And then it will be replaced with the account access key, right? So this is how I am not disclosing my credentials here. Rather, my credentials are stored in, let's say, a locker, and I am just trying to highlight that, right? No one can access it, and this is a secured way. In industry, if you are working, it will be this way. You will not hard code the credentials, right? So dbutils.secrets.get, right? That means I am getting it from this scope and this particular credential. There will be many different credentials stored. One for, let's say, ADLS account, one for SQL DB, one for something else, like that. So I'm saying I want the credentials for our storage account, ADLS Gen 2, right? Now I will show you how to configure this. Only if it is configured, then we are able to call it. If it is not configured, we cannot just call it this way, right? So let me show you how do we create this key vault. How to create or set up the key vault. Let's see that. Okay. So what I will do, I will come here, home. Okay, and we have created TT healthcare KV. I'll write it. We have created TT healthcare KV. This is what health hyphen care. Okay, this is what we have created as a key vault. So once you create the key vault, you will have the secrets, right? Secrets, you can see. So Once the key vault is created, you will add some key and value. Key will be this kind of thing, and value will be kind of the password and all. So how to add that? Just like we have added this. So we have added the password for SQL DB. We have added the password for ADLS account, right? Password for we have given the password for this Azure Databricks access token, right? Access token is given, and Azure Databricks. So multiple things we have done, right? So ideally we are using only one of it, right, for Azure Databricks, but two are mentioned. That's fine. I'll show that. But generate, right? You have option manual. Give the name. Give the name, that what kind of credential it is, so that you can remember it later, and give the secret value here. Give the secret value here, and even if you want to give an expiration date, do mention here, right? So if you see, for example, if I am giving Azure SQL DB password, so you can see it's being added, right? It's being added. You can see you're not able to see the secret value, but you see what's the name given. SQL DB PWD was the name given, and secret value is stored, right? So that means, think that this is like a locker. Here you can store multiple things, right? Multiple secrets you can store, right? So in our case we have stored four secrets: password for SQL database, password for to connect to the storage account, and the credentials to connect to my Databricks, right? Databricks. So SQL password, whatever password we would have set while creating the SQL database, that would be the one. For storage account, you remember, right? For storage account, if I go to my this thing storage account, and I go to access keys, right? This will be the key that I am talking about. This key, this I have stored there, right? That's the like a password. Think it this way. And for my Databricks, if I come here, go to settings, and go to developer access token, right? Here I generate a token. Once you generate, you cannot see it here. So once you generate, you see it, you copy that, and that access token I have put there, right? So I go to key vault again, right? So there are four secrets that way. These two are same. Think it this way, but SQL DB, storage account, and Databricks. Okay, this is all set. So this way you have done it. Now I'll write it. Create the secrets, right? Create the secrets. Now, now one more thing. When you are accessing, so I will go to workspace, setup, ADLS mount. Now you see TTHCKV, our name was different, right? Our name was different, TT Healthcare KV. Then what is this? This is the scope that we created in Databricks. So there is a way that we create a scope in Databricks. So first is you create it in Azure portal, right? We created it with this name. We enter certain secrets then. After that, in Databricks, what you need to do, you take this URL till net, right? This thing. You take this URL and then put hash here, and then say secrets slash create scope. You have to create a scope in Databricks, right? So this way you give a scope name. So we have given the scope name as this one, whatever I was showing you. This scope name we have given, TTHCKV, right? Give that scope name, creator or all workspace users, whatever you select, DNS name and resource ID. How do you get it? DNS and resource ID. So go to properties of a key vault, right? I'll just show you that. uh, properties, and you see this vault URI and resource ID. So give the DNS name and resource ID, and you can find it here. You can see resource ID and URI. This one. So this is given, and that's how scope is created in Databricks. And now we can use that scope. So if you see here, that scope name is used, and this is something which we have already set in our key vault. So if you go to the key vault, we have added this as the secret, one of the secret. I'll show you. So TTADLS access key dev. So TTADLS access key dev, right? So I'm saying I want the what is the secret key for this one, right? We are trying to get that rather than how hard coding the account key, right? So I hope you can understand this part. I hope this is clear. And also one more thing, right? So if you want to access this key vault, if you want to access the key vault from different services, we have to basically do a thing that we have to create the app registration, right? So these are basic things related to Azure, you would be aware, but not if not, then at least I'm highlighting to some extent. Okay, all applications. So you can see we have already created some apps for. So there will be one app which we would create for Azure Data Factory, right? There will be one app which we will create for Azure Data Bricks, right? So you see Azure Data Factory, some spelling mistake, but whatever, right? And then one for Azure Data Bricks, and even we can like we have for uh, storage, right? One for storage, one for so different services if they want to interact with Key Vault, right? If they want to get access to the Key Vault, then you have to do that app registration. So Azure Data Factory, Azure Data Bricks, and then what we need to do once you create this app. So how to create this app? New registration and create it. You can see how exactly has to be done. For example, if I click on this, let's say, so you can see this app is created. This app is created, and once this app is created, what you need to do? Go to the key vault. So if you want access to the key vault, go to the app registration, create a app, create a app for the, let's say, uh, service. Let's say it can be Azure Data Factory or Azure Data Bricks, whatever it is, and then go to the key vault. I'll write it here. Go to the key vault, right? Here you can see, and here go to access policies, access policies. Okay, and now here you will see you can say create and whatever permissions you want to give. Let's say you want to give get and list permissions, right? Just an example. I'll just move this up, and then you say next, and then you enter that app name here, whatever app name was there. So let's say I have something related to ADF. Let's see if or TT hyphen something. Yeah, you can see this app names whatever I have. So to this app you can give that permission, and that app is bounded to that app service, let's say Data Factory or Databricks. So this way, from the portal, Azure portal, you are able to give access to Azure Databricks to interact with the Key Vault, and what permissions we have given, let's say get and list or whatever it is. So that's how it has to be done, right? So, I mean, in case if you find it confusing, then do let me know. I can mention more about it, can create a document, but these are basic things. So I do not want to go too deep into it. So you basically created a app with contributor access and all, and then you basically go to key vault access policies and then select that app and give some permissions, whatever it is, right? And that's how we can access that. Otherwise, you will get access denied and all of that. So at a high level, this is the thing, but this is a basic thing. I would not say that you get hooked to this thing too much in the project, because this you can learn separately also. Because I cannot cover it in too much detail as part of this project. Okay, so this is fine. Key vault is set, and that is where if you go to our this thing, data factory, right? Our data factory. You remember we have put hard coded the tokens and all. We will use the key vault now. We'll use the key vault now. So this was the one. Let me just see. So basically, link service is where we hard code, right? Link service is to connect, and that's where we provide the tokens. So let me just show you the link services. It's here. Link service, and let's say I'm not sure if this. Okay, let's say this I have used. You can see this, right? So we are using access this key vault here, right? And one more thing, important thing is, you remember what all link services we have created earlier? What all link services we created earlier? We earlier created a link service for to connect to Azure SQL DB, if you can recall, right? We created a link service to connect to ADLS Gen 2, right? So this is using a password, this is using a access token, and then Delta Lake, right? For the audit table thing, right? We have that, and then we said we should be creating a link service for key vault. But last session or part one, we have not created a key vault, so we have not created a link service. So now in this session, we should be creating a link service for key vault, right? So this will be a new one that we will create in this particular session. And also, we would have data our code written for silver and gold in our Databricks, right? So we should connect to Databricks also, because our data factory should be able to connect to Databricks to execute that notebook. That means the data factory should be able to connect to Databricks, and for that also link service will be required. Our data factory should be able to connect to Key Vault also to get the access tokens, right? So for that also link service is required. So these two new link services we have to create. Let us first create these two then, right? So a link service to connect to Key Vault, a link service to connect to Databricks. So for Key Vault, you see the name TT, HC stands for healthcare, KV stands for Key Vault, LS means link service. A good naming convention, right? And here we are entering the base URI for the Key Vault. So uh, if you go to the Key Vault, you will see this base URI, this one. This URI is mentioned here, right? And then you can test the connection. Can test the connection, it works, that means fine. We have created this. We have created this link service. That means from Key Vault it can access the things now. Now, this database we have done earlier, Delta Lake we have done earlier. This one is not in use, zero, right? So ignore that. This is the one that is used. ADLS storage account is done earlier. Now Databricks again we have to do. So this one is done. This one we have to do now. right? So we have created TT, HC, ADB, LS. ADB stands for Azure Databricks. So this is because my data factory should be executing my notebooks, right? When we complete the pipeline. So now you see this name. By the way, what is this auto resolve integration runtime? So, I mean, in case if you want more resources for your Azure Data Factory, then you can create your own integration runtime. But I am going with the available one, right? Now, I'm entering the Databricks workspace URL. How do you get? This is here, right? This one. This one is the one Databricks URL. And I'm so if I have to connect to Databricks, not everyone can connect, right? I have to give some token. What token was that? Again, I mentioned it. If you go here, settings, developer, access tokens, generate new token. Only once you will see, copy that. Otherwise, you will not get it again, right? That same token you could have provided here if you would have mentioned access token. But I do not want to hard code that others can see. That's where it is there as part of the Azure Key Vault, right? It's part of Azure Key Vault, and that will be one of the secrets, right? That will be one of the secrets. And what's the secret name here? You can see TTHCABDWS right? This one. This is the one. That means I've stored that token as part of this. I've stored that as part of this basically, right? This one. I hope this makes sense to you. And same thing I am using here, right? I am using here. So I mentioned what link service and what secret name, and there can be multiple versions of it. So last version, last one. And whenever you connect to this Databricks, then you have to say whether you want to create your new job cluster or use existing interactive cluster. So I'm saying use existing one, right? Use existing one. I hope this is clear, right? Okay. So this way you would have understood the things. I'll cancel this now. I'll discard the changes. I do not want to do any of my changes here because it's all set properly. So we have created Key Vault and we have created Databricks. Now, when we were connecting to Delta Lake or ADLS Gen 2, now we would be having that as part of Key Vault only now, right? So you see this ADLS, right? So I think in this still Key Vault is not there, but now we can mention Key Vault and select the link service, select the secret name, right? I won't save it but because I do not want my things to break. But you see the secret I can see here ADLS access key dev like that, right? But I will cancel it for now. So this is how I can basically use the details from the key vault rather than hard coding, right? So with this we have created two new link services and totally we have five link services now. Now, in terms of data sets, what data sets we have created earlier? Data sets, you remember, right? So, we have created a data set for Azure SQL, right? We have created for delimited text, more like a flat file, right? And then we have for Parquet, and then we have for Databricks, Delta Lake. All of this we have done earlier and we do not need any more data sets as such. This is done, right? And always you remember we create a pipeline would basically we refer to a data set here, and data set internally refer to a link service, right? This is a flow which I have mentioned very well in my part 1. So we are good now. We have implemented two link services, so link services are done. Now, what I want to do, so what we have done, we have implemented the key vault, we have implemented the additional link services. Now, let me show you how to implement active and inactive flag, right? Active and inactive flag. So let me show you that. So I go to my data factory, sorry, data factory, correct. I'll go to my Azure data factory. Okay, launch studio. I go to pipelines. Earlier, we had just one pipeline, which is uh, this one, source to landing. This was the one. Right now we have broken it down and all. I will explain again. But let me just see once. Okay. Earlier we had this pipeline where we had a lookup activity, right? That means we were reading the config file here, if you can recall config file. And for each entry in the config file, we were seeing if the file exists. If it exists, move it to archive, right? I'll just click here and show that. Anyways, uh, yeah. So if file exists, move it to archive. If file does not exist, then okay, fine, move ahead. Now, earlier we had this if condition. If then we were checking whether it's a full load or not. So if you see, if we are getting full load from the config file, then implement a full load, else incremental load. Now you can see we have disabled this. We have disabled this activity now, right? Why? Because now we want to, before executing this, we want one more thing, whether the active flag is 0 or 1. If it is 0, do nothing. If it is 1, then do this thing only, right? So you see if condition. So this is disabled, even though it's a part of pipeline, just to show what was there earlier. After this, we have added one more step, if condition, right? And if item dot is active one, that means from configuration file, if we are getting one, that means the pipeline is active actually. The pipeline is active. You can see this. The pipeline is active, and if it is active, that means if it is true, then do execute pipeline one, else do nothing. Now, if I click here for this, right, and I say execute pipeline one, so it is basically the same thing which we have commented there or disabled there, right? So here we are checking if load type is full, then do a full load, else do a incremental, right? So whatever we have disabled there, we brought a if condition checking whether the pipeline that active flag is 0 or 1. If it is 0, do nothing. If it is 1, then check if it is full load or not. And if it is full load, do this, otherwise do this. We have seen that. The only thing is we just brought one more thing, right? So if you see, we just disabled this. Earlier this was there. We removed that. We got this to check active or inactive. And if it is true, we are doing this again. If it is true, you see this, right? We execute pipeline one, which is nothing but the same. I hope this makes sense. So that's one change we have done. Also, we want to make this pipeline parallel, right? We want to make this parallel. So if you see here, if you see here, sequential, earlier we have checked in sequential, but now we have removed. That means this, for each activity, this main part, everything will be done in parallel, right? And you see the batch count is 5. That means in a batch, 5 activities will be running in parallel. So you see, we will be doing things in parallel, and since we are not having a auto increment thing there, parallel will be supported. Earlier, if auto increment is there in audit table, it will not work. That's what we have mentioned, right? So now, what have we done till now? What have we done till now? If you see at a high level, we implemented implemented the active inactive flag, right? That means if in a config, if active if this flag is 0, that means please do not execute right now. We do not want this one to execute. If it is 1, then execute, right? We implemented the key vault, right? Again, I have given some highlights about key vault, but in case if you do not know, then you can learn it, right? That's a thing. And apart from that, we made the pipeline from sequential to parallel. How we did that? By removing the this thing auto increment from the audit table, and by not checking the sequential button in the pipeline. These two things we have done. Also, we created a linked service for Azure Key Vault, right? And we created one more linked service for Databricks. For Databricks, anyways, we have not used it till now. Databricks, why we have created this link service? So that my data factory can connect to Databricks and execute that notebook. Right? Till now, we have not done that. I hope this would make sense to you. Also, we have improvised on the naming convention, improvised on the naming convention, naming and folder structure. This is what we have done, right? Now, what we will be seeing now is that how to bring other data sets to the bronze. Till now, we have just brought the to EMR data to the bronze, but we have claims and the codes, right? What codes were those? If you see, we have NPI, ICD, and CPT. NPI, ICD, CPT, right? These codes we have to bring to our bronze layer, right? So we will see this now. So now, as I mentioned, the claims and CPT will be almost the same style, because those will be in landing. The flow is landing to bronze, right? And in landing it will be in CSV, in bronze it will be in Parquet. That's the difference. Now, talking about NPI and ICD codes, right? This will be from your this will be from API. If you will call a API and bring it to bronze, so there is no involvement of landing, right? So let us first see these two API calls, NPI and ICD codes, right? How to bring it to bronze in Parquet format. So I have my Databricks, right? I have a folder called as API extracts and ICD codes and NPI. NPI is doctor related codes, and ICD you have understood, right? So NPI gives me doctor related details. So I will first show ICD codes, and I will show at a very high level. I mean, even I cannot write this full code myself, right? So you can always take help from Chat GPT and any such sources on how to call these APIs and understand more about it. So request module will help us to call the API Spark session, because we will be writing it right as a Spark this thing, and some Spark functions, all of that. Now, in this is a public API, right? This is a public API. So we have a client we have registered and got a client ID and client secret, and here is the base URL. Date time dot now dot date, that means from the current timestamp it will give us the date, whatever it is. Now auth URL. So that means how it works is that from this, using this client ID and client secret, we will get the authentication token. So to get the auth token, we again call this particular this auth URL, right? So it says connect with this, connect token. So it will get us the token. And what we have to pass to this client ID and client secret. And we are saying these are client credentials that we are passing. Please give me the token. Now this will give us the token actually, right? So this will give me the token which we are collecting. So from the JSON, we are getting the access token now. So that means what we have done is we passed in the client credentials and got the access token, right? Access token. This access token we will use to call the API now. So we are, as part of authentication, we are passing the access token. We are saying API version is v2, language English, right? Whatever it is, and after that, I'm not sure except language what does that mean, but yeah, you can check it out. These are basic things, the boilerplate codes that you can see. And now what we are doing, we have this extract codes, right? We have this extract codes uh, function, right? Fetch, and from this, basically we are calling this fetch ICD codes, right? So we have this, we from this internally we are calling this, and what it's doing basically is, if child in data, right, that means, see, there might be some top level things, and then until we reach to the leaf level, please iterate over it, keep iterating until we reach to the leaves, right, so that we get the exact codes, right? So we keep doing that and we extract various fields out of it, like ICD code type, code description, inserted date, updated date is current flag. So I mean, I could have done a override to it so that we do not require insert update and inserted date, updated date is current flag. This is more like if you implement SCD type 2, which we have implemented for EMR data. If you want to do the same, then you can keep it this way and do append, right? Instead of override, you can do append, because let's say you end up rerunning this two times, then somehow your data should not get messed up, right? Or if new updates are coming, how will you tackle? So either you can do a override, or if you are doing a append, then make sure you implement some logic, right? And that kind of logic we have implemented for EMR data. You can just see that same thing, right? So these are the fields we are extracting. And now this, we are calling this particular function, right, with root URL, this, right? And this root URL, we are giving a very specific thing, release 10 2019, and get me all the codes from A00 to A09. Otherwise, see, there are so many things, it will take a lot of time to run. So I just want to give you an idea how it works. So that's why we are saying only get me records for these things, right? Not more. Otherwise, it will keep running, right? And next time you can run from A0, A10 to A20, let's say, like that. And once you get this, you want to put it as part of this structure. That's where I'm saying struct type, right? So whatever we would have got normal, everything is string. We want to give data types to that, right? So that's why we have defined a schema using struct type, and then we are creating a data frame, Spark data frame. So you see spark.create data frame, ICD codes, we have got the data and we are imposing this structure on top of it. Right? Earlier it would be all string. We are now imposing this structure that, okay, it's not all string. Make sure this is integer, this is date, all of that. So you give the data along with the schema which you want to impose, and then this data frame you want to write in Parquet format in append mode, right? You better to write it in override mode so that you do not have to deal with anything. But if you feel there can be changes which you want to maintain history and all, keep it append, right? And save what place you want to save it, slash mnt slash bronze. We have created the mount point earlier, right, for bronze, landing, silver, everything. So you want to keep it in bronze under the folder ICD codes, right? That's how it is. And if you want to see the data, I mean, this is how it is. This is working code. I will give you the code also. ICD code one A00.0 ICD code type ICD-10, code description, cola due to Vibrio, whatever, right? Very technical language for healthcare, uh, right? All of this. But I do not want to go too much in the API, but at least you would have got an idea that we want to give client secrets to get the token so that we can call the actual API. In the actual API, we are calling a subset of thing, right? So that we get limited records and we will get the parent level thing, which is not the actual these details. So we have to go down or until we get leaf level details like this, right? So you can explore more. I will give you this code also to you, and this will be now sitting it our I mean it will be going to our ADLS Gen 2, and here storage browser, blob container, and under bronze you will have this folder which we have created. What was that? ICD codes, this one, and data will be in Parquet format. And internally you see part files and all, because uh, it's all parallelism, right? So if we have a parallelism level of 4, then 4 part files will be created and so on. So if you know Spark, you would know why these part files. Okay. So this ICD code, I am sure you would got have understood. So now I will show you NPI. NPI is nothing but doctor related details, right? What is that? National provider identifier, or what is the full form, right? So again, importing the modules, uh, getting the today's date, creating a Spark session, and base URL. This is the URL, right? And then what version? Version 2.1. Again, I am calling a limited set so that I do not get stuck with API calling. State for California, city Los Angeles, limit 20. That means I'm just restricting it to this much. Request.get base URL, I'm passing this URL and this parameters. I'll get a response, and this response will give me the NPI codes. That means the 10 digit or whatever identifier which we have. Right? It will not give me more details, but those 10-digit codes only. Right? So it will give me an NPI list with some numbers. Now, once we get this numbers, I want to get more details for this person, right? So that's where I iterate over this list of 20 NPIs, right? Which is a number, and I say, give me detailed response for each of them. Give me detailed response where I will get, let's say, the first name, last name, and lot of other details, like first name, last name, position, organization name, right? All of that. So we take all of that, and again we write it in Parquet format, right? As the override mode, and slash mnt slash bronze NPI extract. So how it works is, first we get the NPI numbers, right? And then we get detailed information from those numbers. And we are writing it in Parquet format in NPI extract folder. I'll just show you that. Uh, NPI extracts, this one. So you can see again, this was a Spark job, so multiple part files. I hope this is clear. I'm not going in too much detail. You can explore. I will give you this code. Right? If you are from healthcare, you understand these APIs much better than me. Right? But at a high level, you see this is the code. So you see NPI ID, right, which is a unique 10-digit identifier, right? And first name, last name, position, organization, last updated, refresh date, whatever, right? So you see this is how the details are there. This we are calling for 20 such doctors, right? I hope this is clear, and this details are from California, Los Angeles, right? Limit 20, that way. So we have got this data, and I just want to give you a highlight on this. Now, one thing to note in our data, like patients' data and all, right? Also, we have NPI code and all. We have used dummy codes. So, actually, we should not be using the actual one because it points to the actual doctor, actually. So, NPI code is generally starts with one. Starts with one. So, let's see if it is starting with one here, right? NPI code starts with 1. But in our case, it might not be starting with 1 because we have created dummy when we were using this patient's data and all, wherever NPI codes we have used. But whatever we have fetched, this is actual. This is actual. So NPI code starts with 1, but in our data sets, it's different because we cannot use the actual one. We should not be using. However, it will be 10 digits. In our what wherever we are using also it is 10 digits. But we have created dummy data sets and we should not be taking the original one. Now, another thing that you have to understand is data extracted from the APIs, we have done a very limited call, right? Is very less because we restricted that. So when you make join, we so when you make join, you may see lot of nulls, but that's fine. We have to understand the logic because otherwise these are public APIs will take a lot of time to run, right? If you can somehow collect a dump from somewhere, it's fine. So keep in mind that this API extract is for demo. If you want full data, please change the URL and extract complete data, but it may take a lot of time. Make a note of that. Now let's talk about. We understood about uh, NPI and ICD. Now talking about claims and CPT. How to bring this claims and CPT? How to get it from landing to bronze? So it should be there in landing actually. So if I go to landing, a vendor or third party would put it CPT codes and claims to landing like this, right? So you see claims. This claims is from hospital 1. This claims is from hospital 2. And you can see this also. You can download and see. But anyways, if I check the other one, CPT codes, if you find the right API, you could have got from APIs also. But I just could not find it. So CPT codes I'm showing as part of this, right? So this is a CSV file again. So we have to get this from this landing folder and put it to bronze in Parquet format. So how to do that? We will be doing as part of our notebook. And we could have created, so as part of this notebook, just like we have created silver, we could have created bronze and got the data from landing to bronze that way. But I mean, just I did it as part of silver only, but you can take this segment out and put it as part of bronze if you want, right? So for claims and CPT codes, I have done that way. That particular logic, a very small logic, you can move to bronze folder if you want, but this in silver also it is okay to keep. So even though I'm under silver folder, but I will be showing these two notebooks and I will be showing a partial code here which will populate my bronze this thing path. So let me first show for claims, right? Now this is my Databricks notebook spark.read.csv /mnt /landing claims. So if you see here claims and then you have CSV files here start.csv. That means if even there are two files, it takes. Okay, header true. Then what we are doing claims df.with column. With column, that means we want to add a new column to this data frame. Right? We want to add a new column. And what is the column name? Data source. Because that file internally there is data source will not be mentioned as part of the data, right? So if I download, let's say, so anyways, same file is here also, right? If you see, so the data source was not mentioned, but we want to I'll just show you that, create one column with the name data source. This was not there, we want to create. That's where we could get it from the file name itself. From the file name itself, let's say hospital 1, hospital 2, right? From the file name itself we can get it. So that's where we are adding data source as a column which we want to add. And what will be the value for this? When input file name contains hospital 1, then hos A. When input file name contains hospital 2, then hos B. Otherwise, none. That means when input file name contains hospital 1, it will give hos A as the data source, right? Otherwise, it will give hos B. And that's what you can see is populated here. That is what is populated. Data source hos A or hos B based on the file name, right? We are displaying this claims data frame. So only one change, one extra column we have added, and how we derived using the file name we derived. Okay. And what we want to do now? What we want to do? So now we want to write this data frame claims df dot write dot format parquet dot mode override, right? And dot save. I want to save it in my bronze under claims folder. Slash mnt slash bronze slash claims, and it's in parquet format. So these two things only. If you want, you can create a bronze folder just like I have created for silver, and you can do, but it's fine. I mean, even you can do this here also. It's just that I read the data from landing, added one more column, and now putting it as parquet in bronze. Remaining is part of silver, which I will explain later. Right? First, I want to set my bronze layer itself, right? So this is fine. Now next is CPT code. Same way we have for CPT codes. So I will open CPT codes here, right? Only one file. So CPT codes df spark.read.csv. We are reading this, right? Whatever number of files. And what we are doing, we are basically renaming the columns, right? We are renaming the columns to lowercase, and wherever there is a space in the column name, we are replacing it with underscore, right? So how we are doing it? For column in CPT codes df.column. So this will give a list of all columns. Let's say if there are 5 columns, if this loop iterates 5 times. And for each column, it see if there is space, it replaces it with underscore. If it is uppercase, it replaces it with lowercase, right? And then in the data set, we are renaming the columns. So there is a transformation with column renamed, and we are giving old column name and the new column name. The old column will be replaced with new column, right? And then CPT code df dot create or replace time view. This was not required anyways. This is just to showcase you the data. Procedure code, CPT code, right? And then procedure code description. I hope this makes sense. Okay. And if you see, we will be writing this in parquet format. CPT code df.write.format parquet mode override, where we are writing under bronze CPT codes. Right? So if I go to my bronze layer now, you have one folder for CPT codes, one for claims, and data will be in parquet format. Right? I hope this makes sense to you. This uh, HOS A and HOS B is for EMR data. Claims is for claims data. CPT code for CPT codes. ICD codes and NPI, this we got from API directly. These two were not in landing, right? So this way, all my data is now sitting in bronze, and this bronze layer can act as the source of truth. And if my data engineering team wants to see this data, take it forward to do anything, they can do. but this is not clean data as such. Not much of cleaning and all has been done. So this is raw data, I would say, but sitting in the right file format, which takes less storage, have right compression. Things are set, and this bronze layer is set for us, right? So now, since everything is under my bronze layer, now next step would be that how to take this forward to silver layer by doing some cleaning, by implementing a change data capture, right? Or like a SCD type 2, or implementing a common data model, whatever. So now we will be seeing how to implement our silver layer. So let us see now bronze to silver. Bronze to silver. Bronze is all set. Now we have to take it forward to silver by implementing a few things. Now, I mean, we have many data sets. If I just take it from what we have written earlier, where are the names, right? This is EMR data. This is EMR data. We have then claims, right? And we have uh, claims and CPT, right? CPT, and apart from that, NPI and ICD codes. These are the data sets that we have. Now, if you see in the EMR data, this small data would be, I would say, providers and departments. There will be hardly a few doctors in a hospital. There will be hardly a few departments in a hospital. So this we will be doing more like a full load, right? That means we will override without implementing a SCD. So we were doing a full load for this and this, right? So no need to implement a SCD here. In all of the others where we were doing incremental, then we will do a SCD. We will implement SCD 2. Here also we will implement SCD 2. SCD 2. That means all the other places we will implement SCD type 2. Now, if you understand it for one at one place, you can understand at any place, right? So, if I show you one full load scenario, like uh, complete refresh scenario, complete refresh. That means overriding, and no need to maintain the history. And one is a place where we have to implement SCD type 2, right? If I show one table for this and one table for this, then you should be clear about the approach, right? So let us start with the full load or the complete refresh, which is very, very easy. Ideally, everything is easy, but complete refresh has nothing as such. So I go to the silver folder. Silver folder has details on how to move it from bronze to silver. But you know, claims and CPT codes even have some code to bring it from landing to bronze, right? So let's start with claims. Claims anyways is SCD2, right? So I will start with F, right? You see departments F, providers F. That means these are the two places where we are doing a full refresh, and other places we are implementing a SCD type 2 so that we maintain the history in case if something changes. So let me show department, right? So what we have to do, read the data in Parquet format from bronze layer. So spark.read.parquet /mnt /bronze. And since department is a part of EMR data, we have it as part of house A or house B, right? So hospital A, let's say, and we are reading same way for hospital B department. We are creating two data frames. You can see this, and then we are trying to do a union. Ideally both of this will have the same structure, so we are doing union by name, right? So how union by name works, if let's say First table have columns like A, B, C. The column names are A, B, C. Second table have columns like B, C, D. Right? Then here, I mean the common after union we will have A, B, C, and D. And since this second table do not have A, it will come null here. First table do not have column D, so it will come null here for the first table, right? And whatever B and C are matching, that will never be null in such case. So I mean based on the column names, it will do the union by name. So data frame has a dot union by name, data frame has B. That means both of these data sets we are combining together, right? If there are 5 rows from the first data set, 5 from the second, it will be 10 rows. And we are assuming the structure is same, schema is same. Now, after this, what we are doing after this is, let me see if I have the data sets to show you. Department. If I open one also, then it's fine. So we have department ID and name. That's it. That's what we have. Department ID and name. And let me see from this, what do we have? We again have department ID and name. So, I mean, right now both the hospitals have same things, but it can happen that one of the hospital have one more department which is not there in previous hospital, right? Or department ID and let's say department 12 is pathology here, and in the other one department 12 is, let's say, surgery. That can also happen. So that things can happen. So what we need to do, we need to make sure these kind of, even if those things are there, that if department is there in one hospital and not in another, that should not disturb our logics. So what we want to do is, so here if you see what we are doing with column, that means whatever we have in department ID, we are creating one more column named source department ID, and same values will be copied. So we will have one more column source department ID which will have similar kind of data like department ID, because we are getting it from source. Source can be hospital A or hospital B, right? From whatever source. Now what we are again doing is we are generating one more column department underscore ID. And now what we want to do, if we can club this, let's say department 001 along with the source from which source it is coming, like hospital A or hospital B, then we will be clear and there will never be any confusion, right? So we are concatenating department ID hyphen and then data source. We are doing department ID hyphen data source. And if we do that, we will never be running into any challenges as such, right? Now, when we move the data to Parquet, right, we have data source also here. In our landing, it was not there, but in our bronze, it was there. So remember that part. So we club this, so it will become like, for example, department 012 hyphen hos B. That means this department belongs to hospital B, right? And then what we are doing, we are dropping this department ID column, because whatever this is there now, it is under source department ID. You can see this. I hope this is clear. Now, that means now it will be source department ID, which is this kind of column, name, which is this. Again, then we have department underscore ID, which is something like department 001 hyphen hos A, department 002 hyphen hos B, like that. And we have source that we have. Now, we want to move this data to silver table. So we want to first create a silver table. Create table if not exists, silver. So basically silver is what? Silver is nothing but a database name like a schema inside my Unity catalog, right? So create table if not exists silver dot departments. So silver is the database name or schema name. Departments is the table name. And we have department ID, that means department underscore id, which we newly created here, source department id, right, name, so data source, and basically we have is quarantine, which I will show what it is, right? So is quarantined is, let's say, if some record fails data quality check, right, then we will quarantine that record and we say quarantine true. Quarantine means, oh, keep it isolated, right? It should not go with the right data. So any bad record should be quarantined, any good record should not be quarantined, right? So we apply some data quality check and bad data will be quarantined. Quarantine will be true for all the bad data. And this table structure is kept in delta format, right? Delta format. So we have created a table structure. Now since this is a Python notebook, right? So if you see, this is a Python this notebook. We if we want to run any SQL kind of this thing, we run this percentage SQL, right? I hope this is clear. Now, if there is any data in this table, silver table, in case of rerun or something, I truncate this because it's always a full load, like a complete refresh. So truncate table silver dot department. Initially, it will be no data, but from next time it will make sense to have truncation here. Now we want to insert it into silver table. So table definition is created, we truncated it, now inserting it. So insert into silver dot department and select department underscore ID, a newly generated column. Source department ID, which we were getting from the source file. Name, right? This name. Data source, we in our Parquet file we had that in bronze layer, right? And case when we have a case statement. Case when source department ID is null or name is null, then true. That means if source department ID, this if this is coming as null or this name is coming as null, then we mark quarantine as true basically. Then true, else false. And so case statement end here as is quarantined. So we will understand is quarantine true or false. True are the ones which are bad data. False is the one which is correct data. From departments. Departments is this table which we have, right? Departments is this table that we have. We created this, right? Departments. I hope this is clear, right? So this is a full refresh every time because this is hardly a few records. But kind of we have applied a common data model also to some extent because if there is same department in both the hospitals, right, then we are not dependent on that, right? And it can happen that hospital 2 is bringing one new department which is not there in hospital 1. So that will not change our logic. Our logic is independent of the hospital now. It cannot mess up our logic, right? So this is about a full load. Let me go back now. Same way providers. Provider is nothing but your doctors. I'll just quickly show you this. We again read it from our, see, it's when we are reading from bronze, it's always Parquet that we read. Spark.read.parquet. MNT bronze hospital A provider, MNT bronze hospital B provider. Right? We again do a union by name, right? Create a temp view with the name providers. Okay, and you see if we are just bringing this, and this data source was coming as part of this Parquet, right? You remember in bronze we have that. So what we can do now is, as a next step, we create a silver table. We create a silver table again using delta format, right? So provider ID, first name, last name, specialization, all of these things is quarantined to have this data quality checks and have true or false. True means bad data, false means good data. We truncate this table, right? Now we insert into silver dot providers, select distinct provider ID, that means we are handling if there is any duplicates or something, right? So any duplicate records and all. So provider ID, first name, last name, specialization, all of this, and cast NPI as in. So any casting by default it will be string, I believe. So we are casting it as integer, okay, and data source. Case when provider ID is null or department ID is null. That means whether provider ID is null or department ID is null, then true. That means it's bad data. Else false. And as quarantine from provider. So I hope you understand. Same way we are doing. So once you understand one full load scenario or complete refresh scenario, then it is easy for us to identify. Right? So this is all fine. This should give you clarity now. Now, what we do, we go back again. So we have seen both the full loads. Now we will see if we see one SCD type 2 where let's say data change is happening and we have to maintain the history also, then how to do that. So let me take let's say patient data for that. Patient data. Patient data will be more data, patient keeps coming, patient details can change, all of that. So again, we read Parquet from bronze hospital A patients, bronze hospital B patients, and create temp view, whatever, right? I'm just showing you like select star from patients hospital A. So we have patient ID, first name, last name, middle name, SSN number, phone number, gender, date of birth, address, and there will be few more things. Modified date, data source. So we are reading this from bronze. Now what to do? So customer address can change and all, right? That's where STD2 is required. We want to maintain the history. So we are same way seeing the data for hospital B, right? Hos B, okay. Now we want to, for this patients, we even want to implement a common data model, CDM. For patients, we have to implement SCD2, that's one thing, SCD type 2, and we want to implement a common data model, CDM. That means there can be different column names and all, right? So let me just see the patient data. Let me just see once. So we have ID, first name, last name, and here let's see if there is any difference. So you see here we have patient ID, column name is patient ID, and here we have ID, right? Here we have first name, here we have F name, right? Here we have last name, here we have L name, middle name, here M name, and so you can see column names are different. Some of the column names are different, and apart from that, let's say this, that's the change that we have. Then how do we bring it under a common schema? That is what is common data model, right? So what we are doing, create or replace temp view CDM patient. CDM means common data model. CDM patients as select concat. So now again, it can also happen that let's say this ID for the patient, right? Hosp 10001, and this you can see this IDs can also clash, isn't it? Might be both the hospitals are keeping patient ID same way, right, under the same kind of structure. Then how will you differentiate whether this is from hospital B or hospital A, right? You have if you club union this, you will not understand from which hospital it is coming. So that's where we have to even say patient ID hyphen, and we have to club it with the data source. We should be clubbing it with data source also, right? So let me just show you this. create or replace time view CDM patient, a common data model as select concat source patient ID hyphen data source, right? So source patient ID, I will just show you source patient ID. One second. Uh, so right now, if you see, this is patient ID and this is ID. Is there anything called as? Uh, I think we will be deriving that concat source patient ID hyphen data source as patient key, uh, comma star from now. That means I want columns, all the columns, but apart from that, so whatever I have this, I want all these columns plus I want to create one more column this way. From this, so consider this as our table now, right? So select patient ID, right, as source patient ID. You see this. From first one we were getting patient ID and from second one we were getting ID, right? So we are naming it as source patient ID. First name, last name, middle name, all of these things I'm keeping as it is from patient's hospital A, union all. Now I will talk about hospital B. Select ID. In the hospital B it was ID, so we are again naming it as source patient ID. F name as first name, L name as last name, M name as middle name. So you see, I'm giving it as similar names now, right? All of these I am giving from patient hospital B. So this is how I am bringing it under a common umbrella, right? And the schema would be under CDM patients. And there will be one extra column which is source patient ID. That means whatever ID column hyphen data source, whether it is HOSE or HOSB. Because if both of them have duplicate, let's say if the patient ID is 1 in hospital 1 and patient ID is 1 in hospital 2 also, then how will you differentiate? That's where we attach the hospital from which hospital it is coming using this data source, right? Okay. Now we say select star from CDM patient. You see this patient key we have generated newly. Hospital 1 hyphen 001. That is whatever key was there. Apart from that HOSE or HOSB which we have added. And source patient ID. That means we are not even touching that. We still have this. That means what was there in the actual source. First name, last name, middle name. So earlier these names were different, column names were different. We brought it under this common this thing. SSN, phone number, gender, right? Address, modified date, data source. So you can see now we have this, right? One table which have everything now. And in a way that it will not be messed up. We can easily identify from which hospital it is coming, right? So different schemas we merged into one, all of that. So CDM is implemented. Now after CDM, so CDM is implemented, done, right? Now quality checks we have to do. Quality checks. Okay. So create or replace temp view quality checks, right? This name we are giving as select patient key or whatever. Case when, now this extra thing is case when source patient ID is null, right? Or date of birth is null, or first name is null, or right? First name lower, it is literally it is null, right? In string. Then we say that this should be quarantined. Quarantine should be true. Then true, else false. End. And the name of this column is quarantine. Is quarantine true means bad record. Is quarantine false means good record from CDM patient. That means we are adding one more column is quarantine. And if it is data quality is mismatched, then true, else false. Right? And you can put more checks here if you want. Now, if I say select star from quality check, order by is quarantine descending, then you see first name is null, right? Then it came in the quarantine thing and it will be quarantine true. I hope this is clear, right? Some of the bad records are here, but I have still not eliminated this bad records, but we can identify these are bad records. So this quality checks is done using a case statement, and we quarantine that. That's the term used, quarantine, right? And now we load this data into silver table. So first we create the silver table structure, create table if not exists silver dot patients, right? All whatever columns are there. We have, so you see this, three more columns. Inserted date, I'll just show you. So for quality checks, what is that? Is quarantine, right? Is quarantine, right? You see this column, right? For CDM, we brought under same column names and all of that. Now, if we want to implement a SCD2, we require these columns. SCD2 is basically, let's say, let's say my name is Sumit, right? Uh, I am, let's say, staying at some address. Let's say I am staying in Hyderabad. Uh, Hyderabad. Let's say I am staying in Himayat Nagar. My address is Himayat Nagar. Right? First time this data is coming. Then when at the time this data came, then let's say this data came first on 11th November 2022. This record is inserted. So when it is inserted, the insert date will be this. First time when this record is coming, right? So insert date will be, inserted date will be 11th November 2022. Modified date also I will keep the same that time. When I am inserting this record, modified date also will be the same when it is inserted. First time this record is coming for this person, right? And is current will be true, because first time this record came, so this will be current record, of course, right? Now, let's say my address changed, right? Sumit, same person identified with some identifier, let's say the patient ID or whatever. Now I am changing my address from Himayat Nagar to, let's say, what place is Tarnaka. Tarnaka is a place in Hyderabad, right? Then my address change on, let's say, 1st January 2024, right? So I will say, so it is coming, this record is coming on 1st January 2024, right? So what we will do when this comes, the insert date I will mention as, so first, when this record came on 1st January 2024, what I need to do, I need to end it the previous record. So what I will say, modified date 1st January 2024, right? Modified date I will make 1st January 2024, and is current will be made as false for the previous record. I am talking about the previous record, the Himayat Nagar one. 1st January 2024 modified date. So inserted was this. Modified it this. That means this record was valid from 11th November 2022 to 1st January 2024. And now this record is no longer valid currently. And now I have to insert this record. Insert date should be 1st January 2024. Modified date also should be 1st January 2024. And is active should be true. This way, I know that this person, Sumit, stayed in Himayat Nagar from 11 November 2022 till 1st January 2024, right? Because and is no longer living there, not current. And currently he is living in Tarnaka, and he started living there from 1st January 2024 and is currently living there, right? So this is the way we can maintain the history. SCD type 2. That's where we require inserted date, modified date, and is active flag. Inserted date, modified date, and is current. Right? I hope you understand this. So, what we will do now is merge into silver dot patient. That means we have to put the data to silver table, right? So, that is a silver database, patients table, which is my target. So, whenever we are doing this, we have to understand what's our target table and what is our source table, and we merge the data into the target. The target is nothing but in silver it is patients, right? And source is nothing but, source is what, my source just now I have this above table, right? What we created, I will see this. Source is quality checks, because this is what I will be using now. Source is nothing but quality checks, because quality checks have been performed on this. So now I will take the data from source, which is quality checks, and I will merge the data into the target table, which is silver.patients, based on the above logic which I have mentioned to you. We will implement SCD type 2, right? So we created silver table, and after this is the merge. We will see this. Percentage SQL, because this is a Python notebook. So percent SQL means SQL code we are writing. Merge into silver.patients as target using quality checks as source. Now, what should be the key column which I need to check, right? For patient, if they have to uniquely identify a person or patient, it will be patient ID, right? So here it is on target.patient key. So not patient ID, rather patient key. Target.patient key equal to source.patient key. Because if these two keys are matching, that means if something is already there in silver table, one record is there and new record is also coming, then I understand that, oh, there is some update is coming for that person, right? So when this is matching for the same person and is current true, that means we see that some, that record is active now. If this is matching, that means for me, let's say my patient key is 101 for Sumit, right? I have a record for Hyderabad, let's say, what was that? Himayat Nagar, and it was, its current was true. This is a active record. Is active was true. Now again, one more record came for 101. So I understood that, okay, there was a record existing for this 101 and it was active also. That means I should implement a merge scenario now, right? There is a clash now. I should merge. That means some update is coming, right? So you see this. So when this is matching and is current is true, when these conditions are matched, then what we need to do, that, oh, is any column changed or not? So you see, if target dot source patient ID not equal to this, right, what we are getting, or first name, is there any change in the first name, or if there is any change in the last name or middle name, right, we are checking that if any column is changing. So we understand that, okay, if any of these columns are changing, then update this, right? If any column is changing, then we have to do this. What we have to do, we have to set what I mentioned, that I understand one new record is coming for this person, and now or record was already there, so I have to end date this. What I need to do, I need to make the modified date. So you see this modified date I will make as current timestamp. So I will just take this here. One second, I will take this. So assume it was like this, right? Now I understand one more record came and one of the column has changed, right? Because I'm checking for that. Then what I need to do? Immediate thing that I am need to do is, let's say on 1st January it is coming, so modified date I need to change. Modified date will become, let's say, 1st January when the record new record came, and is current, or what is that? Is current, I will make it false. Right? These two changes I have done. That means we have undated this previous record. We have updated this, and updates are possible in delta table. That's where delta table supports updates, right? Because of delta logs and all, it supports that. I hope this is clear. We have undated the previous record, right? Now, if see if it is matched, then we have done this. And if it is not matched, if not matched, then what does that mean? What does that mean? So remember one thing. In the previous case, we have edited the previous record, but we have still not inserted the new record which came, right? So ideally, I should insert again a record for 101 Sumit, and I should say Hyderabad uh, and Tarnaka, right? And I have to make it as active, right? Is current, I have to make as true, and I have to set insert date and modified date. I'll just mention. So I'm yet to do that. I have not done. Insert date, it should be 1st Jan 2024, and this should be 1st Jan 2024. So whatever we have done till now here, we have not done that. We have just ended the previous record, but this is yet to be done. I'll write it. Yet to be done. Right? Now, when 101 or some record was matched, then we did and dated the record. So this when not matched will, it will come to this when the record has not matched. That means it's the first time this record is coming. Then definitely it will just do a insert, right? It will mark it as true, and current timestamp, both modified date and insert date is current timestamp, first time record. Now, remember what we are yet to be done. We have undated the previous record, right? In case of update, we have undated the previous record, but yet to enter a new entry for that, right? So let's go down in this notebook. Let's go down in this notebook and see. Merge into silver.patient as target using quality checks. On when patient key is matching, right, and target is current is true, this is true. When not matched, that means this this particular scenario, when this is not matched, then what it will do, that means we have made it at false, right? So it will be a case for the update scenario. It will be a case for your update scenario where a new record has to be inserted. So when not matched, then we are inserting that. We are inserting this. You see this, inserting a record, and source dot is quarantine, this current timestamp we are mentioning, current timestamp and true. So this will go as inserted date 1st January 2024, modified date 1st January. So assuming 1st January 2024 is today, right? Let's say. So we have done handled two cases, right? One is the case when it's a new record, then it's a simple update, right? Nothing has matched, it updates, it inserts basically. When when it's a update scenario, when a record was there and new record has come, then we end dated. In this, we did two things: end dated the previous one, and marked it as inactive, right? And then inserted a new one, right? So this, the way you inserted a new record versus the way you inserted a update record, it's same. Actually, it's same. So that's how you implement SCD type 2, right? I hope this would make sense to you, right? And now You can check it out. Whatever you have, you can just have a look at it, right? You can run basic queries to see whatever you have done is correct or not. So this is done, implemented SCD type 2. I will show for one more quickly, implementing of SCD2, and then same way it goes for others. Let's say I'm talking about transactions, right? We read it from both Parquet, right, the bronze layer, and we did a union by name and created quality checks where we implemented whatever if nulls, we quarantine that same thing, and then we created a silver table definition, right? So if table already exists, it won't create, otherwise it will create. It's a delta table so that updates are supported. And now whatever quality checks we have created, right? That's our source, and silver table is the target. So merge into silver dot transactions as target using quality checks as source, and the criteria transaction ID and target is current is true. Same thing. When matched, when matched, that means when these conditions are matched and any of the column has changed, then you ended the previous record. Audit modified date, current timestamp, and is current, you make it as false. That means you are saying the previous record is invalid and it has become invalid on this date, right? Then what you will do? Now you basically have to, if there is a new record which is coming, or for the update record you have to insert, right? That will happen here now. Merge into silver dot transactions using this, everything is same when not matched. So in this both the cases will come. One case is when it's totally a new record there, first time this particular transaction is coming, or it will even when it's a update when target or this current is false now, right? So it will not match then also. Then it has to insert, and insert becomes same way. We put the current date as both our modified date and insert date, and its current flag will become true, right? So that's how you implement SCD type 2. Same way you can do it for any other uh, data set. So basically here what we are doing, we are implementing quality checks, right? Or in some of the cases, we are implementing a common data model. That means if we have different schema, we are bringing them under a common schema. I will say common schema, right? Or if there can be clash in the IDs for both the tables, we again are giving a surrogate key, right, by appending the hospital name to that. That is what CDM is. Quality checks is basically we are checking for nulls and lot of other things, and quarantine the bad record, quarantine bad records, right? And apart from that, we are implementing SCD2 where we are maintaining history and dating the previous record and so on. All of this we are doing here, and the structure is same for all of these silver tables or silver notebooks, right? Now, silver is done. Now we will check that how to take it forward. But before that, when you talk about claims and CPT code, there is a bit of more code to bring it to bronze also. You see this, right? That's fine. After that, we started bronze to silver, right? So pattern is same. You create a quality checks table, right? And then create a silver table, move the data from quality check to silver, right? And implement SCD2, all of that. That's fine. I will give you all of this code. I mean, it will be an overkill if I keep explaining other notebooks for silver. So now we need to check on the gold layer. Gold layer. Silver to gold. Okay. Now silver to gold is pretty straightforward, very, very easy. Let's quickly look. So I will go to again my data bricks, right? And I will go to my gold layer. I'll just show you what exactly we are doing here or what's our thought process. Let's say I take patient, right? So what I will do, of course, I have to create a schema in the gold layer, right? So gold is nothing but the database name or schema name, and dim patient is the table name. So dim underscore stands for that it's a dimension. So some of the table will be so if you would see this, right, so accordingly there will be few, not this, sorry, my bad, uh, this one. So some of the table will be dimension, some of them will be fact. Now in our case we have just one fact. We could have multiple facts ideally, but this is just to demonstrate, right? So transactions is a fact and remaining are dimensions here. So if I just show dim underscore patient, that means it's a dimension. We are truncating it. Now we want to insert into it, from where we will insert silver layer, and that's how we are following a medallion architecture, right? So we are taking, but we do not want to bring inactive records, that means the history and all. I'm not interested, I am only interested in the latest record. That's where in gold layer we are saying that is current true, because there will be, let's say if this patient detail has changed 5 times, then there will be total 6 records in silver, right? But in gold, I want to bring the latest record, which is the active one. So where is current equal to true? And also, I want to not bring the bad data. Is quarantine false? Anything that was quarantined, I do not want to bring it forward. Let it quarantine. It should not come out of the room. Like that's how it happened, right? During COVID days, that oh, this person is in quarantine, he will not come out, right? So same way that is quarantined in that layer now. So is quarantine false. That means all the records which are good will only move forward to gold layer. So uh, two things: is current true, right? And is quarantined false. These two things we are bringing, so that we are bringing only quality data and we are bringing only newer data, right? This is the only thing that we have done, and you can see we are showcasing it. This is all working code. I will give you the notebooks, you can try. Right? If I keep running everything, it will take a lot of time. So before this session, I ran it so that you can see the outputs. Okay, fine. So that's about this. Now, if I show you, let's say, dim patient, that's what we saw, or, right? So only this thing is current true, is quarantine false. Based on this, we will try to get the data. So you can see this, it's very straightforward, nothing to talk much. I'm seeing if there is anything else that I need to highlight. I'll quickly open these notebooks just to check. Right? Create gold table, truncate it, bring it the data from silver table, but bring only the good records and the latest data. That's the only thing that has to be done. And gold layer is set. Our gold layer is set now, right? Right, so gold layer is set. Only so silver layer will have more data, gold layer will have less data, only the proper data, and that too in the form of facts and dimensions. So our facts and dimensions tables are created. Next what? Next what? I mean, ideally we say gold layer we can use as part of our like final business end user queries, right? So there are some gold queries like based on the KPIs and all. So you see this. So this basically in a SQL warehouse, the query is written, and you can start a serverless this thing 2x small, that also take 4 dbus per hour, which is also a lot by the way, right? So make sure you use it wisely. So any query like total charge amount per provider by department, or total charge amount per provider by department for each month of year 2024. These are the end user queries which are there. So let's see this for example. Uh, so we are using in this fact transactions table, and uh, transactions fact and provider dimension and department dimension. So we are joining these three, and we want to find total charge amount per provider per department. It can happen that a doctor might be associated with multiple departments also sometimes, right? So provider name we have, department name we have, and then we will do group by. So how group by all works is, any non-aggregate column, you see some we are doing, apart from that these two are non-aggregate columns, right? Then it will consider both these columns, otherwise we would have to manually mention group by provider name, department name, unnecessary. So this is a cleaner syntax, and will group by based on provider name, department name, right? So any non-aggregate columns, it will kind of group by based on those which are used in the query. So we are getting this, and again we can do it for each month also. So provider name, department name, and we can get the uh, month also, year month. Again, group by all is a very neat syntax to do. Otherwise, you would have to mention these three columns here in order to do that. So you see, we are trying to find the end user, this thing, uh, like business queries, provider name, department for in the month of January 2024, total charge amount, total amount paid, all of that, right? But for claims related and encounter related data, we have not, we didn't proceed it in fact, right? We could have also created fact table for those so that we can calculate some KPIs related to that. But we have not done as part of this demo, but that could also have been done, right? So you can see this reporting can be done on this gold layer, right? That's the thing. So you understood about gold queries. Now, final pipeline. Right now, I have shown you bits and pieces, but everything has to be integrated through Data Factory, right? So let me go to my home, and I go to Data Factory, ADF dev, right? Now we have one end-to-end pipeline. When we run this, it will invoke the notebooks also. So if in case you someone has to run this pipeline, what needs to be done is you the audit table, truncate the audit table, then you can run it from scratch. And I mean, why we are truncating? Because we are not having newer data. If we have new data, then even we do not have to truncate. Incremental will work. But since the same data is there, it will not do anything in the second iteration in that case. So better truncate and then we can run. So if you see the pipeline, this PL end to end healthcare is the one. PL end to end, right? So what we it do is, if you see, execute PL EMR source to landing, right? So whatever we have seen earlier, source to landing, right, which we have seen in previous sessions, I will show you that. We check the config file, we see if the file is there, we move it to archive, right, and then see if the is active flag is 0 or 1. Accordingly, bring the EMR data and bring it to your this thing, bronze layer, right? Whatever was that, it is there. This is that one, right? I hope this is clear. And then what has to be done, we have to execute notebook. Once the data is in bronze layer, then we have to execute notebooks to take it to silver to gold. So this is the one, this is the one after that. So you see that what is executed first. So if I click here, you will understand what notebook is this. So it is using the Databricks link service. Otherwise, Data Factory will not be able to call this notebooks, right? And which notebook path it is saying, right? You see here. So if I take this and show you the notebook path, right? It is transactions notebook under the silver, this thing, right? this transaction notebook under the silver, and this is the transaction notebook under the gold, right? So first this is executed, and then this is executed one by one. So first, I mean, the flow of data factory pipeline is ADF. It brings, or basically it gets the data to bronze layer. And we are in part one itself, we have seen how to get it using a metadata driven pipeline where we have a config file, and as part of it, we are having EMR data, which directly is coming to bronze, right? And then we have again claims data. Claims data, you remember, as part of silver layer itself, we have this that it comes to bronze also, right? And then we have various codes, right? All of these things are there. We have seen all of that. So bronze we were doing as part of the previous pipeline. If you see this one, right? This is that pipeline which we have seen lot many times. And once this is executed, then it will have this silver to gold, and it's all connected using end to end, right? First this part to move it to bronze, this part to move it to silver to gold, right? And that's where our this link service for Databricks was required in order to do that. Now also one thing that you will notice, we have implemented retries. So you can see many places we have added like retry to, and each retry interval is 30 seconds. So we can do that. At some places not done, but other places it's done. You can also configure retries as part of good practices and all, right? So this is our pipeline, and if I want to run it, what I need to do, I need to truncate my audit table. So let me go back to workspace, and I go to as part of this setup, I have this audit DDL. I will try creating a small, whatever small cluster I had, right? I will turn it on. It's a very small cluster which will consume 0.75 dbus, 4 cores and 14 GB I get, standard D3, DS3 V2, right? So I am just turning it on. For this, I could have even done it using this my this thing serverless starter warehouse, right? I could have even done with that, but fine. I'll turn on one cluster because it's required now. So I will truncate this table, and then I will run the end-to-end pipeline that we have. That end-to-end pipeline will take care of all the activities, taking the data from our Azure SQL DB, bringing it to our what bronze layer in Parquet format, then again calling the notebooks to take it from to silver to gold. All of that it will do, right? And it's a metadata driven pipeline again. So let's wait for the cluster to start. And in the meantime, I'll show you one thing that when we were talking about this, right? So you can see here this particular uh, claims and encounters. It is only in silver, not gold. That means right now we are not creating basically the gold table for this. So we are not having this claims and encounter as part of facts in gold layer, right? So if we want to handle more KPIs, serve more KPIs, then we should be even creating that. But for this demo, I don't think it's required because you are still getting an end-to-end flow, right? Let's wait for the cluster. Cluster should be up very quickly. So my cluster is up. I will quickly truncate this because there are some entries inside this audit table. And then I will show you how to run the pipeline. And the pipeline will run in parallel. That's the best part, right? Batch size is 5. So basically, again, this is the catalog name in Unity catalog, then table database name, and then table name. Done, truncated. Now, what I will do, I will go to my end to end pipeline and I will run this, right? So, let us see now. So, if I can see here also, or I can go in monitor tab and I can see it there. So, let's see, or let's say monitor, and here there is a debug mode. So, I have run it earlier also, so I can see that as well. I will say last what custom. Okay, last half an hour if I would see. So, anyways, these are the new ones, and let's see how it's happening. So you can see this is executing. Now you see, as part of this end-to-end pipeline, we have EMR source to landing, right? EMR source, that means you take that EMR data and bring it to bronze. Actually, not landing, it should be bronze ideally, named as bronze. Do not get confused because EMR data we are directly bringing it to bronze, right? So EMR source to bronze actually, that is getting executed. Now, if I let's say click on this, if I click on this, you see multiple things are happening. Multiple things are happening parallelly, right? So it's not that it is doing it one by one for each table. It is acting, or it is doing it for all tables together, right? So you can see this. So it's running in parallel now, and this should complete very very quickly because it will not take much time. It's not going to take much time. One thing is that when it runs, you can see what parameters were passed, right? For what thing it is running, like PL copy from EMR, right? So full load, what database name, table name, all of these parameters which we have passed through our config file, right? You can see here to understand more. That means for which thing it is running and how it is running, all of that. I hope you can understand all of this well. So this should be done, and it won't take as much as time it has taken earlier, right? So you can see this out. And by the way, if you have a bigger integration runtime, more resources, then things will happen more quickly because again, we have acquired very limited set of resources, right? So that is also one thing. If you acquire more resources, it will be much, much faster. So by mistake, I have put different timings. So if you see, a lot of it is completed, right? You can see this. And what is that? You can see full load and what hospital, right? Trendtech hospital, whatever. You can see the value here, table name and data source. What parameters are being passed to this? So a few things are running, and I think that should also be complete very, very quickly. So this pipeline internally has all of these things which are running underneath, right? So copy from EMR, there are a lot of these things. Silver to gold is happening now. You can see this. Silver to gold is running, where we are calling that notebooks, right? That is running. So I think it should be done very, very quickly. So how cool it is that we have just this pipeline, everything is integrated, right? Such a good pipeline we have created end to end, where we got the data from various sources, put it to bronze layer, then silver layer, implemented CDM, right? Implemented data quality checks, implemented SCD type 2, brought it to gold layer, right? Perform some end user or reporting queries, right? And integrated all of this in a single pipeline, used best practices like key vault, naming conventions. Of course, I have to show one more thing, that we have even used this Unity catalog, right? So if I go to catalog, then you see here, this is to keep, I think, the audit table, audit, right? uh, so this is the catalog name, TTHCADBWS. That's the catalog name that we have given. And inside this audit is to keep audit table, audit database, right? So database or schema is same thing in Unity catalog. Then we have gold schema. All these dims and facts are here, right? Then we have silver. All whatever tables we have in silver are here. So you can see. And one more interesting thing. If I show you, let's say, uh, for example, let's say patient's data, I can click on lineage. It shows me that what is next. What is the downstream to this? Downstream to this is the gold layer, right? Dim patient. That means from this part, I am sending the data to gold.dim.patient, right? Let's say encounter. I will again click on lineage. So encounter we are not putting, right, to gold anyways, yeah. So let's say we are putting patients, right? You see this downstream, you can see that where does the data go from this part? It goes to gold dim patient, right? Which notebooks are referring to this? We see the notebooks referring to this, all of that, right? I hope this you can get a clear idea. So very very interesting. And the role of this catalog is very good, that it acts as a central meta store. So if you have more Databricks workspace, those workspaces can also refer to this. So I hope you would have got quite a good clarity on this. Now, the last thing is we can sync up this code with GitHub and create a new branch and all. I'll just give you some idea. If you do not know about Git and GitHub, you can check out my videos on YouTube. I have a complete 4 hours video on that, right? I will provide the link in the description. Now, just I will give you an idea how we do that to sync the code. Uh, we basically go to the GitHub account. I have a GitHub account, right? I go here and go to settings, right? And I go to developer settings. Here I can go to personal access token, tokens classic, and I can generate a token. I have already done that earlier, right? So I will not create. I can generate a token which I will just capture. I cannot see it later. I have generated this for Azure Healthcare project and gave certain permissions. Now, once the token is there and once the username, you should know the username of it or of your account, right? For example, mine is Big Data by Sumit M, right? That's the username. So once you have the token, two things, the username and token, right? You get from your GitHub, and then you go to your Databricks, right? Go to click on this and click on settings, linked accounts. Here you have this GitHub. I mean, it will show you multiple options, right? So if there is a other workspace, I could have shown to some extent. Let me just see if I have something else, because this is already integrated, right? This is already integrated feature code, you can see. But let me just check that out. Uh, if some other random, I will see. Okay, let me see. This is not related to us, but I'll just show you what I'm trying to convey. So I come here, I say settings, I click on linked accounts, and here I select GitHub, personal access token. I provide the uh, username and the token, right? I provide the username and token here, and then it kind of shows up. So that's how you can link this up, right? It's already linked in our case. You see feature code. I mean, you can create a new branch or whatever you would like to, and you can do that. So for now, I mean, I do not want to go so deep into it. That can be a separate topic itself. But you see how neatly we have, uh, wrote our code, segregated in different notebooks, and we have covered a lot, right? We have covered a lot, and this should give you a very, very good idea. I don't think there will be any project which is available on YouTube at this level, right? Now, I mean, just in case if you want to check about SQL videos or your Git and GitHub, I have separate playlists on my YouTube. You can check it out. I will provide the link in the description. And to support this initiative, I mean, I would just say that if you like my videos and you appreciate what I'm doing, you like this video, post about it on LinkedIn, what you have learned, and share it with your friends so that others should know about this quality stuff. You know that this kind of stuff you do not get it for free. I'm very sure you would be aware of that. And in case if you do not know, I offer a ultimate data engineering program, and I will provide the link in comments. In case if you want to master data engineering to a level which, I mean, very few people can master up to that level, right? If you want to reach that level, then you can, I mean, consider going for my ultimate data engineering program, which is a program which has impacted several careers. And if you have not yet subscribed to my channel, do subscribe now. And I'm very sure you would have truly appreciated all the efforts put in this project and you would have learned a lot. So, with this, let me end it up. Thanks a lot. And if you have seen all of it, definitely you are much ahead than others. Thank you.